Good morning. Good morning, everyone. How was Sunday? Huh? Horrifying. Sleepy. Sleepy Sunday. अच्छा, चलो अच्छा है. You have one class only, ना, in the day? बचे हुए हो अभी तक? हाँ? Sorry? पूरा? वीक भी क्लास है? नहीं, फ्राइडे सैटरडे तो छुट्टी होगा ना? या उस दिन भी क्लास डाल दिया आप लोग? नहीं डाला ना? बच गए यार. अभी तो काफी ब्लेस्ड हो. दिन में एक ही क्लास हो रही है ना? अभी तो 3-3 कराएंगे हम. ठीक है. ऐसा घबराना नहीं है. गेट यूज टू ईच अदर. है ना? यही शक्लें दिखेंगी सुबह से शाम तक. कई तो बेड वेड लेके आ जाते हैं. छत पे ही सो जाएंगे सर, जाना कहाँ है. ओके. चलो. सो ऐसे ही थोड़ी आईएएस का तैयारी हो जाता है ना? सही है सर. हाँ ठीक है, जो भी है यही है सर. ओके. गुड. सो yesterday we had covered up to the temperature factors. वो कर रहे थे ना, temperature factors affecting temperature. Alright. And in that we had done up to ocean currents. So factors affect, so ocean current, how does the ocean current, this was the diagram. Just give me a second. Sorry. हंसना नहीं यार, मेरा भी पर्सनल लाइफ है. आज सुबह ब्रेकफास्ट खा के आ गया चुपचाप से. विश तक नहीं किया. माय वाइफ हैड हर बर्थडे. अब वापस भी जाना है. आप लोग का तो कुछ है नहीं. है ना? घर आना. वहीं मिलेगा. सॉरी. ट्यूसडे. पता नहीं आज रात में क्या होता है, उस पर डिपेंड करता है ना कितना. मेमोरी पुअर होने का एक घाटा है. आई सी द डेट्स ओनली इन द कंप्यूटर. तो कंप्यूटर यहीं आके ऑन हुआ. शिट. लॉजिक क्या लगा है अपडेट में. मतलब मेरा क्लास मुझे भी देखना चाहिए. चलो कोई बात नहीं. गुड. सो गुड. So let us come back. Ocean currents. So how do ocean currents affect the temperature? बोलो बोलो, बताना है आपको, बताना है. Yes. Cold currents bring cold water to warmer regions and make the region relatively colder. ठीक है. And we saw that example यहाँ पे. And what happens in the other case? Warm. उसको कौन सा current बोलेंगे? So in case of warm currents, what do we get? warm water is brought to the colder regions and that colder region is made relatively warm. Okay. Okay, so good. Now, so after this current thing, what is the next thing that affects the temperature? Let us see. ठीक है, air mass. So how do air masses affect the temperature? What is an air mass is the first thing that we need to understand. Okay, and then we will see how do air masses also affect the temperature. So I would like you to draw along with me. ये बनाइए diagram साथ साथ में. Tropopause, surface of Earth, okay, and let us say 90 degrees, so this is pole, and then you have 60 degrees subpole and 30 degrees subtropics. Okay, can you see all of you? Right? So now when you consider this whole region, what kind of temperature should I expect in region 60 to 90, and what kind of temperature should I expect in region 60 to 30? 60 to 90 should be colder, the surface will be colder and the other surface will be relatively warmer. So the whole air which is in the region above this zone, okay, the whole air which is in the region above, let's say 90 to 60, at least the surface air and all, what do you expect that temperature to be? The air temperature? Colder. And if the air remains over that region, that whole big region, for a long time without moving much, and let us say it remains there for maybe 10 days, 15 days, 20 days. So we can expect that by, gradual sinking of the denser air, the lighter, the air from above, gradually things will, so the whole air mass might gradually become cold. है ना? So we expect this whole air mass to behave slightly like cold. What air mass matlab? A big piece of air. Okay, so this whole air we expect to be having colder temperature. है ना? Why? Because it is over a cold region. Right, polar subpolar region में है, let us say there is snow on that region, and the other region which is 60 to 30 degree, because that air is over a warmer region, so we expect this whole air to behave relatively warmer, है ना? I hope everyone broadly gets it. ये सारा air warm हो जाएगा. Why? The surface air will get warm, then that air will rise, and as it goes above, it will tend to make the even upper region air as warm air, है ना? So this whole region air might behave something like warm. Okay, ठीक है? So this way you have two regions, the air of which start behaving as per that region. So in the colder region, the air starts behaving colder, and the warmer region, the air starts behaving warmer. Is that okay? Now, so this whole, what is the air mass here? Air mass is this large volume of air, right? So air mass का explanation क्या है? It's a large volume of air which is found over a region which would generally have the characteristic of that region. ठीक है? This is for you. This is not geography option में उसका definition थोड़ा सा explanation थोड़ा अलग हो जाता है. It does pick other characters, but for our GS purpose we don't include that. ठीक है? So यहाँ पे हम कितना बोलते हैं? The air mass is a big volume of air which picks the characteristics of the region over which it is. ठीक है? So if the big volume of air is over cold region, it will pick the characteristic of that cold region and become relatively colder. Is that okay? And over the warm region, it will become relatively warmer, right? So very simply said, one picks the character. Second, there's another characteristic of this. I'll dictate that in a while. The second characteristic is that when you compare this air parcels or air mass characteristic with the other one, they will be pretty distinct. They will not be similar. But if you see the characteristic within it, you will find it to be pretty similar. So within it, it will be similar, and across it will be different. Then you call them as two different air masses. Okay, so one air mass is something which within itself is having similar characteristic, and when compared to another air mass, it will have a different characteristic, right? And they will be uniform and all this. And you can see what is the size. Kitna size hai ye? Around 30° latitude, which would be around 3000 kilometers, and height is up to tropopause, है ना? So it's a big air mass. So air mass is a big volume. ऐसा नहीं, छोटा सा नहीं. मतलब it's not over a city or something. It will be a very big volume that you are talking of. Okay. All right. So this is what we call as air masses. Now, so this is what air mass is. Now the second thing. Let us say, because of whatsoever reason, this air mass tends to move away from this region, and this region starts becoming relatively, not colder. So there wouldn't be anything much here. So this air mass might gradually also shift. So if a colder air mass comes to a warmer region, what will it do to that warmer region? It will start turning that warmer region colder. So this is air mass effect. Okay, what do air masses do? If a air mass which is cold moves to a hotter region, it will turn that region colder, and if a air mass which is hot turns to a colder region, it turns that region warmer. So the temperature of the region is affected by air mass shifting. The way you did currents, इसीलिए मैंने currents पहला किया, because current, once you understand the current logic, current was also doing the same. It was changing the temperature where it was going. This will also do the same. It will change the temperature of the region where it is going. Is that okay? So if this air mass goes to this region, suppose this is removed or gone somewhere, so this region will also start becoming cooler. Is that okay? Okay. So this is how the air masses tend to affect the temperature. Which kind? No, this is not inversion. Inversion is always with respect to vertical. ये horizontal में हम inversion नहीं बोलते हैं. ठीक है? It will lead to some inversion later on. अभी नहीं आया वो. ठीक है? वो frontal inversion है. But वो ऐसा नहीं है. वो कुछ और है. Right? So is this okay? Clear? ये समझ में आ गया? Nothing too complicated, I guess. हाँ. So लिख लें? Yes, dear. When the air mass moves, the whole thing will move. No, otherwise it breaks into two different air masses. If it will break, okay. So it might crack into two different air masses, but generally the whole thing would move. So when you're talking of one air mass, you're talking of either that whole block or the broken block, but you're talking of one at a time. Okay. So write down first what are air masses, right, and then types of air masses, and then third will be how they affect. Okay, तीनों चीज लिख लेंगे. So what is a air mass? What is a air mass? Air mass is a large parcel of air horizontally stretching over hundreds or thousands of kilometers. Horizontally stretching over hundreds or thousands of kilometers. And vertically may stretch from surface to tropopause. Vertically may stretch from surface to tropopause. So it generally picks the temperature and moisture characteristic. It generally picks the temperature and moisture characteristic. Temperature and moisture characteristic of the region over which it is formed. Temperature and moisture characteristic of the region over which it is formed. and stays for a relatively long time, over which it is forms and stays, over which it is formed and stays for a relatively long time. So the region where it is formed and where it stays for some time, then only it will pick the characteristic. Okay, forms and stays for relatively some long time, something like this. Okay, full stop. This way we would have warm air masses formed over warm regions, warm air masses formed over warm regions, and cold air mass formed over cold regions. Cold air mass formed over cold region. Okay, so now effects of air mass. Effect, temperature effect of air mass. If a warm air mass moves to a cold region, it makes that region warmer. If a warm air mass moves to a cold region, warm air mass moves to a cold region, it makes the cold region warmer, and vice versa. Okay, so that's the effect. Done. So air mass हो गया. So how many factors done? Factor number 6 भी हो गया. Now let us come to factor number 7. ठीक है. So 7, in this we add up the same factors that we have done in insolation. Slope, aspect, and one more we'll add shelter. ठीक है. Effect of slope, aspect, and shelter. How do slope, aspect, and shelter affect the temperature of a region? So what do you think? Slope कैसा affect करेगा? More inclined slope was receiving more insolation or less? आपने किया है less insolation मतलब temperature less, simple. So slope, higher the slope, lesser the temperature, simple. वो लिखते जाओ, अपने आप लिख लो. Higher the slope, lesser the temperature. ठीक है, तो simple सा logic. So plains will generally have more temperature and mountains will generally have lesser temperature. Mountain slopes will generally have lesser temperature. ठीक है, example भी साथ लिख लो so that. So plains would generally have more temperature and the mountain slopes will generally have lesser temperature. Then what is the effect of aspect? Aspect हमने क्या पढ़ा था? What did we learn about aspect? Shadow side, or we can say which side of the mountain, है ना? Not always shadow. So it can happen that, let us say, अब ऐसा सोचो. Okay, just imagine. Let's suppose this is the Earth's surface. Okay, and this is the sunlight coming. Okay, and let us say you have a mountain slope which is like this. Right, now both the slopes are getting sunlight, but which one do you think will get more sunlight and which one will get less sunlight? One will get more intense because there the sunlight will be falling relatively more, relatively more from the top, whereas on one it will be relatively more horizontal or more parallel. ठीक है ना? Can you see that? So both of them. So this is aspect. This is not shelter. Shelter कुछ और है. Shelter means you don't see the sun. This is aspect, that despite of having same angle with respect to ground, still one slope will get more sunlight, the other slope will get less sunlight. Okay, so aspect does not mean the second side does not get sunlight. It means that both of them will get different sunlight despite of having same angle with respect to ground. क्योंकि विद रिस्पेक्ट टू ग्राउंड तो ये एंगल सेम है ना, ये दोनों एंगल ए एंड बी. थोड़ा ज्योमेट्री कर लेते हैं, इतना तो समझ में आता होगा ना, मतलब ये तो बहुत ज्यादा नहीं हो गया. सो ए एंड बी आर सिमिलर एंगल्स बट स्टिल बोथ ऑफ देम आर गेटिंग different sunlight. Is that okay? So this is what you call as aspect. Okay. And what is shelter? Shelter means that that side does not receive sunlight. Or if you fall in the shelter of a, for example, let us say that you have a hill like this and this side you have a village. ठीक है, वो V जो है वो village है and this is the mountain. Now the village will always be in the shelter of the mountain. This is shelter. ठीक है, so that village even during the daytime might not receive much sunlight or might receive sunlight only for a very short time and most of the time it will be under the shelter. तो sunlight होगा sky में, they can see sunlight far away but they won't be getting the sunlight for themselves. ठीक है, this is another question that whether such village will ever exist. Will people be so stupid to create a village, you know, just at the foothill where there is, but they do at times because of other resources. जैसा water resource availability है या कुछ चीज के लिए, ठीक है, स्पेशली इन द रीजन्स वेयर लेट्स से ट्रॉपिकल टाइप ऑफ रीजन एंड ऑल, तो वहां पे कर सकते हैं बिकॉज वहां पे एनीवेज यू गेट एम्पल सनलाइट. ठीक है, इज दिस ओके, अंडरस्टूड, राइट? सो दिस इज शेल्टर, गुड इनफ. सो इसमें कुछ बहुत ज्यादा एग्जांपल्स का जरूरत नहीं है, आई थिंक वी गेट इट. सो नाउ लेट अस मूव टू द नेक्स्ट थिंग. सो आफ्टर स्लोप, शेल्टर एंड ऑल, द नेक्स्ट फैक्टर इज फैक्टर नंबर 8, नेचुरल वेजिटेशन. नेचुरल vegetation cover. Vegetation cover which could also be not only but also be forests, right? So what is the effect of natural vegetation cover or forests? ठीक है, now what do you think? First intuition क्या कहता है आपका? What is the effect of vegetation? What does it do to the temperature? It reduces the temperature. थोड़ा ऊपर कहीं लिखो साइड में, डोंट राइट इट पॉइंट में, साइड में लिखिए. ठीक है, माई इंट्यूशन सेज टेम्परेचर इज रिड्यूस्ड बाय वेजिटेशन. ठीक है, तो रिड्यूस करके लिख लो ताकि अभी पता चले 5 मिनट में कि होता क्या है. हाँ सर, आप इतना बोल रहे हो तो जरूर कुछ उल्टा ही होगा, है ना? ठीक है, सो वेरी गुड. सो दिस इज वेयर वी हैव टू अंडरस्टैंड दैट मेनी टाइम्स आवर इंट्यूशन माइट नॉट बी राइट बिकॉज इट इज नॉट योर इंट्यूशन एक्चुअली. You know, it is your partly forgotten type of memory. वो इतना मेमोराइज हम कर चुके हैं कि हमें लगता है कि वो हमारा इंट्यूशन है, बट वो हमारा इंट्यूशन नहीं है. ठीक है, वो हमारा मेमोरी है. Why? Because you are tropical people. आप कहाँ के लोग हो? ट्रॉपिकल पीपल. तो ये हमारा ट्रॉपिकल बिहेवियर है, राइट? इंट्यूशन और बिहेवियर में अंतर होता है, राइट? सो व्हाई एम आई सेइंग दिस? लेट मी गिव यू 2 एग्जाम्पल. जैसा वो पानी के पास खड़ा किया था ना डंडा लेकर के, ठीक है, सो सेम एग्जाम्पल, राइट? लेट अस से यू आर स्टैंडिंग इन अ हॉट समर डे इन अ ट्रॉपिकल रीजन इन अ फॉरेस्ट. व्हाट विल यू फील? बिकॉज ऑफ वेजिटेशन द टेम्परेचर वुड हैव reduced or increased? Reduced. Everyone agrees, and that's exactly why you said that the vegetation decreases the temperature. Now let me take you to another extreme. Let me take you to a tundra forest, polar region, है ना? साइबेरिया का फॉरेस्ट में ले चलते हैं और विंटर नाइट में आप फॉरेस्ट में खड़े हैं, डे में नहीं. कब खड़े हैं? विंटर नाइट में. और उसका थोड़ी दूर पे एक बिल्कुल फ्लैट स्नो कवर्ड रीजन है where there is no vegetation, and then you are standing in a vegetated forest. Where do you think you will feel more colder? Huh? Where will you feel more colder? Where you are standing in barren land with no vegetation, or if you are standing in that forest with vegetation? कहाँ पे ज़्यादा ठंड लगेगा? So what is the vegetation doing there? What is the vegetation doing there? It is warming the, है ना? So it is having a warming effect. So in extremely cold regions vegetation have, and in warm region vegetation has. So क्या effect है इसका? Severing, cooling, moderating. 4 इफेक्ट हो सकता है ना. सेवरिंग इफेक्ट किसका था? कॉन्टिनेंट. मॉडरेटिंग इफेक्ट ओशियन का. कोल्ड करंट, कोल्ड करंट इफेक्ट बताओ. कूलिंग इफेक्ट, वार्म करंट, कभी देखा कोल्ड करंट इज वार्मिंग द रीजन, तो उसका तो कूलिंग इफेक्ट है. तो वेजिटेशन का कैसा इफेक्ट है? इट हैज अ मॉडरेटिंग इफेक्ट. दिस इज व्हाट आई वांटेड यू टू, इसीलिए मैंने बोला साइड में लिखो रिड्यूसिंग. ठीक है. सो वेजिटेशन हैज अ मॉडरेटिंग इफेक्ट, राइट. So natural vegetation in general has a moderating effect on temperature. आपको वर्ल्ड क्लाइमेट सीखना है, इंडिया का नहीं. ठीक है. So it has a moderating effect on temperature. Which means वो भी लिखना है. What does that mean? Moderating. अब वो खुद लिखो यार प्लीज. लिख सकते हैं या someone wants me to dictate? लिख सकते हैं. So we'll be writing during colder regions or in colder, extremely cold region, vegetation will have, in extremely cold region, vegetation would have warming effect and vice versa. Okay, good enough. आगे बढ़े. Very good. So next one is surface, type of surface, the effect of type of surface. So when we talk of type of surface, there could be two set of surfaces. One, color, and second, wetness. ठीक है. Or moisture. Rather than wetness, you can write moisture also. ठीक है. So moisture. Right. Now, what is the difference in terms of color? How many types of surfaces you can have? You can have a bright, or you can say dark and, यही बोलते हैं ना, dark and light color. And moisture wise, you can have wet and dry regions. ठीक है. So let us first complete this moisture wala part, because this you have understood by now slightly. Which region do you think will have a severing effect and which region will have a moderating effect? Dry region. अच्छा, wet region में कैसा होना चाहिए? If the soil has water, moderating effect or severing effect? Moderating effect, है ना? So this region will have a moderating effect. Moderating effect. And soil with no water, such as deserts, so in the daytime or hot period they will become severely hot, and during the night time the same soil might become severely cold. This is something that you might have experienced, the ones who have been to deserts. Desert में क्या होता है? Daytime the sand becomes extremely hot, the same sand during night time becomes extremely cold also. ठीक है. और not, if not extremely cold, at least cold. मतलब extreme cold तो ज़्यादा हो जाएगा, but still cold. Is that okay? So dry region will have a severing effect. Right? So this is wet and dry soils. Okay. Now, in terms of color of the surface, what effect will it have? ये सब आपने साइंस में पढ़ा हुआ है बचपन में. You know, why do you wear dark clothes in winter and light clothes in summer? तो क्या लॉजिक है यहाँ पे? Dark color absorbs heat, absorbs या reflects? Dark color, and light color reflect. So light soils will give you what effect will light soil have? Colder, है ना? So they will generally have a cooling effect. Light surfaces, ठीक है? So light surface will have a cooling effect, and dark surface will have warming effect. बोल सकते हैं? ठीक है? So the surface which reflects more light, we talk in terms of a word called as albedo. Albedo word सुना होगा? What is albedo of the surface? The power to reflect is called as albedo. The power to reflect the sunlight is known as albedo of the surface. वो लिख लीजिए. ठीक है? The power to reflect the sunlight is known as albedo of the surface. ठीक है. So please see here. And which color will have which color? For example, snow color, snow covered region should have high albedo or less albedo. Acha, one more relation I want you to write. Higher the albedo, lower will be the relative temperature. ठीक है ना? Higher the albedo, lower will be the relative temperature because reflection is more, right? Light reflection will be more. Okay, so please see here. For example, अब ऊपर देखिए यहाँ पे snow. If it is a fresh snow, means it has just fallen, right? Which means it will not have any dust or anything on top of it. So it will be pretty bright. If you go to the mountains, by looking at the snow, you could make out whether this is fresh snow or old snow. ठीक है? Fresh snow gives you a very bright glow. वो दूर से ही देख के दिखता है कि ये बिल्कुल bright shine कर रहा है. ठीक है? Whereas the old snow will be generally having a duller white color to itself. ठीक है? So fresh snow will generally have कितना albedo इसका? You can read there. 0.8, 0.95. So it will have very high reflection and hence lower the temperature. Okay, because it is not absorbing heat, it is reflecting most of it. Whereas on the other hand, if you go to a soil which is let us say, ये देखो, asphalt and all, peat, asphalt, जैसे रोड बनाते हैं हम, charcoal. So if उसका albedo will be very less. Why? Because it absorbs. It is dark in color, है ना? So it will, and this is something that you have already felt when you walk on a bare road. वो concrete वाला जो road होता है ना, या black road, उसके ऊपर आप walk करिए तो आपका पैर जलने लगता है. Why? Because it is having dark color, so it tends to absorb more heat. So this is your albedo story. ठीक है, समझ में आ गया? Is that okay? Right? We would try to share this sheet of albedo of different regions because they do ask you. अभी तो नहीं पूछा है, but in the past they have at times asked you this. Compare the albedo of different surfaces. ठीक है, तो ऐसा क्वेश्चन आई थिंक 4-5 साल या 6 साल पहले पूछा है कभी. So you should have, देख लेना. ठीक है, is this okay? Should we go beyond? So surfaces का effect समझ में आ गया. Surface will have only two types of effect. One in terms of their temperature, second in terms of their color, right? And the third is liquid or this thing, right? Solid surface or liquid surface. For example, which surface will have a liquid surface? Oceans, lakes, rivers, they have liquid. And solid surface, land, all the land. What is the difference? The difference is, ये भी एक और वो आप लिख सकते हो, water bodies and land, how they affect temperature. So another factor which works is the water bodies and land. Now, in addition to their heat capacity and all, there is one more factor which plays a role here. What is that? If you have a land and you have a water body, something like this, ऐसा, right? So suppose this is the water body, and let us say the depth of the water body is few kilometers, right? Let us say 3 kilometers. So this is the ocean, and that's the land. And on both of them, sunlight is falling with same intensity. Okay, it's a daytime. So on the coast and the ocean, both the sunlight is falling with same intensity. Okay. Now, how will the temperature of the two regions get affected? This depends on which region is absorbing the heat. So when you talk of the land, right? Land and ocean. In the land, only the top very few centimeters of the region absorbs the heat. Land being opaque, only the top very few centimeters, right? Most probably maximum up to a meter. The heat of the sun will be felt. If you go deeper than that, you don't feel the heat of the sun. That's exactly why when you dig despite of the fact that as you go deeper into the earth the temperature increases, but the top 1 meter 2 meter you start feeling cold. होता है ना, आपने अगर बचपन में कभी किया हो, मिट्टी खोदी है ना, so if you slightly dig that clay, that lower part seems relatively. Why? अभी ज्योग्राफी में तो हमने पढ़ा as you go deeper into the earth the temperature increases, तो increase होना चाहिए, but वो cold क्यों है? That is the sun's effect. Only the top region is getting heated by the sun. The lower region is not affected by the sun. So that is not the normal temperature. The lower one is the normal temperature of that region. The top one is the sun heated temperature. ठीक है? When you go inside, और यहाँ पे क्या हो रहा है? आपने normally क्या feel किया है? मान लो आप you take something and you dig the ground by 1 meter. What will you feel inside? Cold. That's what I'm saying. Why? Because the top surface is heated by sun. What is the normal temperature of that region? What you are feeling inside? That is the normal temperature. On the top you don't feel the normal temperature. On the top you get the temperature heated by sun. Okay? So only the top 1 meter maximum will get the heat of the sun. But in the water bodies, the sunlight is able to penetrate up to a depth of 400 meters maximum, especially in the oceans. Up to what depth? 400 meters. So maximum up to a depth of 400 meters, the sunlight is able to penetrate. Okay, that's why if you take a scuba dive into ocean water, तो थोड़ा नीचे भी आपको sunlight दिखता है, वहाँ अंधेरा नहीं होगा. It's not that the moment you jump into a water body अंधेरा हो जाएगा. ठीक है? So why is that sunlight? So because the sunlight is able to penetrate in transparent water up to a depth of 400. And if it is penetrating to that depth, will it heat that region also? It will. So in oceans, what depth is heated up? Up to 400 meters. On the land, only 1 meter. So difference तो होगा ही. This also creates the difference. Right? All the sunlight heats only the top 1 meter of land, but the sunlight heats up to a depth of 400 meters in the ocean. Okay? That's why the ocean surface temperature is not so hot even during the day, because the sunlight goes down into it. Right? So this whole zone of the ocean where the sunlight passes through, ये पूरा जो zone है ocean का, through which the sunlight goes, is known as the zone of light. Zone of light, इसको बोलते हैं. And what is the Latin word for that? Photo. तो इसको हम photic zone बोलते हैं. This is the photic zone of the ocean. ठीक है? The zone of light in the ocean. Clear? So what is photic zone? The zone depth up to which sunlight penetrates in the ocean, and that is the zone of light in the ocean, and that is the zone which is directly heated by sun. ठीक है? Clear? And this is the reason why the ocean temperature will be lesser than land, because land very less region is getting heated, ocean good depth is getting heated. Clear? Very good. So factors affecting temperature broadly we have completed. Now let us come to, so that's it. These are all the factors which affect the temperature on the earth. ठीक है? Good enough? तो अब उसका आगे बढ़ते हैं. Let us go beyond this. So the next thing that we need to do, once we understand how temperature is affected on the earth, the second is representation of temperature on the earth. Representation of temperature over large regions. Representation of temperature over large regions. How do we represent temperature over large regions on the earth? ठीक है? So should we understand this? I'll take the same diagram of South America. सबसे आसान कॉन्टिनेंट लगता है मुझे बनाने के लिए. ठीक है? ऐसा सा. Okay, so now let us say that these few places that I'm putting as dots, they have a temperature of, let us say, 25 degree Celsius each. सबका temperature कितना है? 25 degree Celsius. So I go on writing on all of them 25 degree Celsius. ऐसा लिख देंगे. ठीक है? And then nearby we have places which have a different temperature. Let us say right, so these places have 20 degree. ठीक है? And then you have another set of places 15 degrees. So one way of showing temperature is like this. You go on drawing, and as you can see, this diagram already looks pretty hodgepodge. है ना? तीन ही temperature दिखाया, right? So this is a messier way of showing temperature on a map, right? Now what you can do is, you can also connect places having same temperature by a line, है ना? जैसा कि I could do something like ऐसा, right? So I could draw one line, and maybe for 20 degrees I can draw another line, and for 15 degree I can draw another line, and then I can most probably rub those numbers. Right? And the whole diagram looks relatively, I wouldn't say it doesn't look messier, but we can say it looks relatively less messier. ठीक है? Now वो 25 थोड़ा रब करना मेरे लिए मुश्किल है, ये तो लाइन भी चला जाएगा. ठीक है, कोई बात नहीं, जाने देते हैं लाइन को, फिर से बना लेंगे, अपना ही लाइन है. Something like this. So now this whole diagram looks relatively कह सकते हैं ना, and you can put number at one end, 25 degree Celsius, 20 degree Celsius and 15 degree Celsius. ठीक है? So this is a method that we have found for showing places having same temperature on a atlas map or a map. तो map के अंदर how do we show temperature? We show it like this, using a line rather than for every point putting a number, right? And that line is called as a line of same temperature, right? Same के लिए word होता है iso, temperature के लिए therm. So नाम क्या हो गया? Isotherm. ठीक है? So this is what do we call these lines? Isotherm line. So what are isotherm line? They are lines showing places having same temperature. बस हो गया. So this is how you represent temperature on a map. ठीक है, वही टॉपिक था ना, ऊपर क्या था? Representing of temperature over large regions. Large region मतलब मैप में. ठीक है, so just draw this and then we write that. Hence, as we see in the diagram, the lines joining places having same temperature line joining places having same temperature are known as isotherm. Iso is same, therm is temperature. Are known as isotherm. Okay, same temperature line. Good enough, right? And if I take the globe and I ask you with respect to this globe, okay, and let me hide ये बीच में जो लिखा हुआ है इसको मिटा देते हैं. I'm just leaving those numbers and बाकी मिटा दिया है, ठीक है? So if I ask you to tell me what should be the relation of isotherm or how should the isotherms be drawn for these different latitude regions, ठीक है? For example, if I ask you 0 degree as compared to 37 degree or 37 degree as compared to 66 degrees, what should be the temperature relation? Temperature relation of ये मान लो यहाँ 75 degrees है, right? So what should be the temperature relation of 75 degree with 66 degree? This is latitude. So 75 degree will be colder than, है ना? And 66 will be colder than 37 and 37 might be colder than 0. वो 23 तो है नहीं, ठीक है ना? So do we agree? Broadly, most of us, do we agree? Very good. And if I ask you that, can we say that these latitude themselves might be somewhat like the isotherm? For example, that whole 0 degree might have similar temperature, if not exactly same, है ना? तो 0 degree latitude तो, if I say that equator has an average temperature of 27 degrees, so that whole line is 27 degrees, that's perfectly fine. And if I say 66, है ना? Broadly I'm saying, broadly. So not same exactly, but broadly. So maybe अगर real में हम बनाएंगे भी, even if we draw in reality, the line might be something like this, है ना? So you can broadly say they are similar, the latitude and the isotherms. Same ways, if I draw the 66.5 degree latitude का temperature graph isotherm, it might be something like this, थोड़ा मोड़ा ऊपर नीचे, okay, having a temperature of let us say 15 degrees Celsius. So that 15 degrees Celsius is the blue line and that latitude is the black line. So seen from a far away distance, they look pretty much the same. So broadly said, what is the relation between isotherms and latitudes? Parallel तो बोल ही सकते हैं, if not same. Yes or no? And here we are not considering any other effect affecting temperature except for, यहाँ कौन सा factor ले रहे हैं? Latitude. आपने factors affecting temperature में सबसे पहला factor what have you written? So here if we consider only the effect of latitude and do not consider any other effect such as, कौन सा effect you are not considering? Altitude, continentality, you know, all that. So if you leave, and by the way, if we consider on the earth, what is maximum, land or water? 70% तो water ही है. So if you have to take an average, you will consider the whole land to be behaving like a water body, है ना? अगर मैं बोलूं कि दोनों में से एक लेना है तो क्या लोगे? वाटर बॉडी. मुझे पता है लैंड आपके लिए इंपॉर्टेंट है लेकिन अर्थ के लिए नहीं है, ठीक है? अर्थ का तो 70% वाटर बॉडी है. इज दैट ओके? So broadly said, this is an earth which is mostly a water body, and on that earth if we just consider the latitude effect, the isotherms will be nearly parallel to the latitudes. Do we agree? ठीक है? So if the earth is nearly water body, we are saying we are considering maritime effect. Maritime को हम neglect नहीं कर रहे हैं, ठीक है? So maritime effect if we consider, then in the case of maritime effect, we can say that isotherms will generally be parallel to लैटिट्यूड। आया समझ में? हाउ मेनी ऑफ यू डिसएग्री? कर सकते हैं, संडे मॉर्निंग है, ऑफिशियल ऑफ है आज। हाँ, हाउ मेनी ऑफ यू अग्री? अग्री है। अच्छा सर, हम ना अग्री करते हैं ना डिसएग्री करते हैं, हम कॉन्टेम्पलेट कर रहे हैं। हाँ, क्या कर रहे हैं आप? यार ये यूक्रेन रशिया को यहाँ लाने की क्या जरूरत है, क्लाइमेट चल रहा है, आप लोग इतना पोलिटिसाइज क्यों हो गए हो? एब्सटेन कर गए। आपको कौन सा एनर्जी सप्लाई मिलने वाला है कि सर हमने छोड़ दिया है? सच बताओ। हाँ, मोस्टली अग्री है ना? ठीक है, वेरी गुड। अब अगले बार मैं पूछूंगा अभी नहीं आप लोगों से। आप सब बहुत ही डेमोक्रेसी के नाम पे आप एकदम अनार्की मचाने में लगे रहते हो। ठीक है, सो ओके, कमिंग बैक, सो दिस मच इज क्लियर टू एवरीवन, राइट, दैट वील हैव अ relatively parallel isotherms with respect to the latitude provided we consider broadly a watery earth. ठीक है, so 70% maritime effect, is that okay? So let us write this down, लिख लेते हैं। So if we broadly consider the maritime effect, क्योंकि वो तो moderating effect भी था ना, therefore, ठीक है, if we broadly consider the moderating effect, sorry, the maritime effect, then we find that over the earth's surface for different latitudes, the isotherms will be relatively parallel. And their values will generally decline from, the isotherm value, है ना, what value it is having, the isotherm value will generally decline from where to where? Equator to pole या tropic to pole? क्या लिखना राइट है? क्या पढ़ा है आपने? Tropic to pole. Equator to tropic, it will increase. It will remain parallel, but it will increase. And tropic to pole, it will decrease. ठीक है, it will generally decrease from tropic to pole. And equator to pole, it will generally decrease. वो parallel lines रहेगा, but वो increase होगा. So equator might have something like, let's say 30 degree, and 23.5 degree will have something like 35 degree. Temperature will increase. So isotherm will be there, parallel also, but is this okay? So decrease from tropic to pole, and from equator to pole it will increase. Isotherms. ठीक है? And if you want, you can write examples also. Right? इसके अंदर हम एक 23.5 भी बना देते हैं for our sake, so that we understand the whole thing properly. ठीक है? तो अगर हम, if we draw 23.5 in this, so what isotherms will you find on this? Nearly parallel, वो blue line करके एक isotherms भी बना देते हैं सब पे। Right, so what values of temperature should we expect? Let us say equator has 30 degrees Celsius, so 23.5 will have 35 degrees Celsius. ठीक है ना? And then 37 might again have 30 degrees Celsius, and 66 might have 15 degrees Celsius, and 77 might have 0 degrees Celsius or 5 degrees Celsius, something like this. So different latitudes and different isotherms. Broadly clear? Right? So this kind of a behavior it will have. Now, should we move on to the next thing? अब आगे देखें. So how do isotherms behave on a real Earth? अभी तक तो हमने किसका इफेक्ट लिया है? Maritime. But how do isotherms behave on a real Earth? Which means which factor we have to now introduce? Maritime के बाद? Which means we have to see how continentality affects the isotherms. ठीक है, so next subheading, how continentality affects isotherms. Many times create the isotherms relatively parallel. Now we'll see what is the effect of continentality on isotherms. So how continentality affects isotherms. Okay, done. This much is done. Okay. So should we draw the other thing? Now let us say here I'll directly draw the the latitudes and then we'll try to draw with respect to that. ठीक है, तो यहाँ पे सीधा latitude बनाते हैं 0 degree and let us say this is 23.5 degree and this is 45 degree and this is 65 degree and something like this is pole. ठीक है, so different latitudes and in that let us add up a continent in the middle ऐसा. So just assume that this is a continental body ऐसा. ठीक है, वो 80 को मैं 90 को I'm just correcting to something like 85 degrees, right? Slight correction. And this is the continent. Continent. So if this is the continent, on the other side you have the ocean. Ocean. ठीक है. Now let us come to our main task. Let us take few locations in the water body and the land ऐसा of the same latitude, but I'm not drawing on those latitude that we have drawn. I'm taking these places, right, and we call this as A, B, C, D ऐसा, and this becomes and A2, B1, B2, B3, B4, C1, oh sorry B3, B4 नहीं होगा, I think वहाँ कुछ गड़बड़ कर दिया मैंने नंबरिंग में. So C1, C2 and D2 and C1 and D1. ठीक है, just draw this much because after this it is your task. I don't have much to do. I'll just set up the playground for you and then you play the game. ठीक है? So once you have drawn this much, after that I'll give you some conditions and then you have to tell me what should happen. आपको बताना है. Right? What are the rules of when you move, and let us say we are talking of one season. Season भी दे देते हैं आपको. Summer. So let us say this is summer season. So we'll use red color. Summer season. ठीक है? I'm not giving you month. I'm just directly giving you the season. Summer season. ठीक है? And let me say that the temperature at A is something like 35 degrees Celsius. Temperature at A in the ocean is कितना है? 35. Now what is the rule? In the summer, when you go from ocean to the land of the same latitude, temperature should, what have you learned till now? Increase. Severity effect. So this everyone understands. This is the first rule of this game. Right? And the second rule, as you go to higher latitudes, temperature decreases. So increase and decrease. You understand which side what is happening? Now what you have to do is, all of you, where you want to increase, increase by 5. And if you want to decrease, decrease by 5, so that everyone has the same answer. ठीक है? So जहां पे भी increase करना है, if you feel that this place it should increase, तो कितना से increase करेंगे? 5 से. And if you feel that this side it should decrease, so कितना करना है? 5. And what is the number you are starting with? 35 at A. So by this logic, for example, at A1 in summer, which is A1 is continental interior location. Summer, what should be the temperature? Everyone agrees? 40 degree. तो यहाँ पे 40 लिख देते हैं. And A2? A2? 35. Very good. And B? B. अब थोड़ा ध्यान से देखो लैटिट्यूड, उसके बाद बोलना है. B. Because you are already beyond 23.5. आप already उसके beyond है. So at B, what should be a temperature? 30. And go on filling all of them now. Fill the whole thing yourself. और अब गलती किया तो आपका मिस्टेक है, मेरा नहीं. ठीक है ना? क्लियर? सो बिना ऊपर देखे चुपचाप फिल करते रहो. और मे बी इफ यू आर नॉट श्योर तो पेंसिल से फिल करो. And once you have filled, please cross check on the board. And please cross check for every location if your answer is same. ठीक है? And what will ensure that your answer is same? You just see that D series. D, D1, D2. अगर वो मैच कर गया तो बाकी सारा राइट होगा. So D, what is the temperature at D? All of you? 20. And D1? And D2? 20. ठीक है ना? Is that okay? Now if I ask you, please draw the isotherm of every given temperature. ठीक है? And if you don't find the temperature on the continent, don't draw it. क्योंकि वो temperature continent पे है ही नहीं. For example, or if you don't find that temperature in the ocean, जैसा 40 डिग्री है, 40 डिग्री का isotherm बना सकते हैं? Do you have 40 degree in the ocean? है ही नहीं, तो you can't draw it. 35 का बना सकते हैं? Can we draw the isotherm of 35 degree? How? Which points will you connect? Give me the point. Number चाहिए मुझे. A, B1 and A2. So this is the isotherm of what temperature? 35 degree. ठीक है? And give me the other isotherms. B, C1, B2 and C, D1, C2 and D का बना सकते हैं? 20 डिग्रीज का बना सकते हैं? Why no? कॉन्टिनेंट पे है ही नहीं, so you can't jump over the continent. ठीक है? Is this okay? So have you drawn the isotherms? Now can you tell me in the summer season what is the effect of continent on isotherm? What is the effect of continent on isotherm in summer season? The isotherm remains parallel to the latitude or bends? All of you can see on the board. It tends to what direction? North बोलना चाहिए या pole बोलना चाहिए? So it tends to bend. So continent or continentality bends the isotherm towards in the. That's it. That's the conclusion. और आपने किया है, मैंने नहीं किया है. ठीक है? So do you understand what is the ocean effect on isotherm? Oceans keep the isotherms relatively parallel. And what do continent do in the summer? They bend the isotherm towards pole. है समझ में? Everyone is clear? So लिख लो please. Right? That as we can see, that during summer season, continentality tends to bend the isotherm. Continentality tends to bend the isotherm towards the pole. During summer season. And northern hemisphere summer will be in which month? Let us say June, है ना, broadly somewhere around June. So now we are writing June also on the top. दिख रहा है? Right? क्योंकि मैंने नीचे एक दूसरा डायग्राम बना रहा हूँ मैं for you only and which you have to fill. So in the month of June, in the southern hemisphere, which season should we experience? Winter. So in the winter, how should the isotherm bend? What do you think logically होना क्या चाहिए? Before I draw this whole thing, इतना लॉजिक भी आप लगा सकते हो अभी. क्या होना चाहिए? In the winter season, due to continentality, the isotherm should remain parallel or bend? Towards what? Earlier it was bending towards pole या north. अच्छा एक बात बताओ, अगर मैं यहाँ पे सदर्न हेमिस्फीयर में समर का डायग्राम बनाऊं तो वो कैसा बनेगा? हाँ, ऊपर की तरफ. Let us say that I give you January, which is January is what month in southern hemisphere? Summer. So let us say we are doing for January summer. कैसा bend होगा? Bend towards north या pole या equator? क्या लगता है? I need the answer from all. दो बच्चों से काम नहीं चलने वाला. हाँ? Everyone agrees? कौन सा pole? North pole, south pole? South pole. So the answer is what? In the summer season, the continents bend the isotherm towards pole या north? अभी हाँ? Pole बोलेंगे ना? Pole. Depending on which hemisphere you are talking of. South में बोला तो South pole, north में बोला तो North pole, depending on the hemisphere, but it will bend towards pole. By the same logic, for their respective winters, for example, northern hemisphere का winter and southern hemisphere का winter, for their respective winters, the continentality will bend the isotherm towards equator. उल्टा होना चाहिए, है ना? एक बार ड्रॉ करके देख लो, अपने आप पता चल जाएगा. I asked you out of logic कि होना क्या चाहिए, but if you want you can draw also. ठीक है, I can give you the same set of locations, similar set, not same. I can't give you same set. So let me say ऐसा चार, and this is I, J, K, L, right? ऐसा करके, ठीक है? And let us say at I, now we have the temperature at 30 degree Celsius. ठीक है? So अगर I पे 30 डिग्री है, राइट, ये I थोड़ा सा 23.5 का उधर बन गया है. So let me just correct it. Just wait 1 second. I, J, K, L, M बना देते हैं. I हटा ही देते हैं पिक्चर से, ठीक है? Rather than doing something else, let me rub this I thing. ठीक है, तो I का लोकेशन हट गया. J, K, L and M. You have these 4 locations. Okay, and obviously 1 and 2. J, K, L, M, 1 and 2. I'm not writing the whole thing. ठीक है, चलेगा? And let us say at J the temperature is 30 degree Celsius. Winter season. ठीक है, जनवरी को हटा देते हैं यहाँ से और इसको जून ही रखते हैं and winter. So June winter in the southern hemisphere. ठीक है, June winter southern hemisphere. These location. How should the temperature behave? K पे क्या होना चाहिए? Temperature at K. हाँ? What should be the temperature? All of you? पक्का? 25. And L? And M? 15. And J1? You are going toward continent. Now be clear. ये winter season है. So what should be the temperature at J1? 25 or 35? Continentality in the winter. कम करेगा, ज्यादा करेगा? All of you agree? So this will be 25 now, and K1 20 and L 1, 15 and M1 10, and same ways J2. Now you are going toward ocean, so increase, है ना, moderating effect, and then 25 and 20 and 15. So आप कौन कौन सा isotherm बना सकते हैं? Can you draw a let us say 25 30 का isotherm बना सकते हैं? 30. Do you have 30 on the land? है ही नहीं, so you can't draw. So 25. तो कैसा isotherm बनेगा? Yes or no? है ना? And 20 का isotherm and 15 का isotherm. So how is the isotherm behaving in winter over continent? Bending towards equator, and in the summer bending towards, so ऊपर June summer bending toward pole, नीचे June winter bending towards equator. Yes or no? So अभी clear है? ठीक है. So this is the isotherm, this is the effect of continentality on isotherm. ठीक है. हाँ जी सर, इसको भी तो हम बोल सकते हैं कि वो पोल की तरफ जा रहा है. हाँ, कौन सा ट्रॉपिक? You're talking of this one? 23 and अच्छा, उसके ऊपर तो हमने बनाया नहीं ना. ठीक है, इज दैट ओके? तो उसको इक्वेटर बोल सकते हैं ना. ऑलराइट, फॉर आवर अंडरस्टैंडिंग. इज दिस ओके? सो शुड वी राइट दिस? लिख लें? एनी डाउट? डाउट है कुछ? पक्का? आपका चेहरा देख के मेरे को लग रहा है, चेहरा तो नहीं दिख रहा, आईज, तो मैं आईज में देखता रहता हूँ. आप लोग अगर इधर उधर कुछ कुछ ऐसा देखते रहते हैं तो मुझे लगता है कुछ तो डाउट है, लग रहा है. अभी ठीक हो गया? अभी विंटर हो गया ना जून के हिसाब से. सो जून है ये. ठीक है, वो मैंने इसलिए किया था क्योंकि सम ऑफ यू आर गेटिंग कंफ्यूज दैट इट इज मूविंग नॉर्थवर्ड नॉट पोलवर्ड. इज इट ओके? सो बट यू पीपल गिव द आंसर, सो आई स्किप दैट डायग्राम. वो स्किप किया है बस, घबराना नहीं है. ओके, चले आगे बढ़े. तो शुड बी राइट? राइट लिखिए. सो आई रेड योर कंफ्यूजन राइट, है ना एटलीस्ट? ठीक है, मतलब ठीक है यार, रीडिंग पावर सही चल रही है मेरी भी, इतना दूर से भी रीड कर ले रहा हूं. आई साइट ठीक है मतलब. ओके गुड. सो लेट अस कम बैक. सो राइट डाउन ड्यूरिंग विंटर, ड्यूरिंग विंटर, ड्यूरिंग विंटर, due to continentality, due to continentality, the isotherm bends. Due to continentality, the isotherm bends towards the equator. ठीक है, all right, very good. Now the next set of things, now you only have to conclude and tell me which hemisphere has more continent. Hence, where should isotherms bend more? And where should isotherms remain relatively more parallel? लिखना है. जो जो ज्ञान आप मुझे देते हैं वो सब ज्ञान आपको अपना कॉपी में भी लिखना है. ठीक है, राइट. सो व्हाट डू वी राइट? दैट बिकॉज नॉर्दर्न हेमिस्फीयर हैज मोर कॉन्टिनेंटैलिटी, right? Hence during summer and winter, hence during summer and winter, isotherms will bend during summer and winter, isotherms will bend more in the northern hemisphere. And because southern hemisphere has more maritime effect, because southern hemisphere has more maritime effect, southern hemisphere has more maritime effect, hence the isotherms will remain relatively more parallel in the southern hemisphere. ठीक है, isotherms will remain relatively more parallel in the southern hemisphere. Yeah, bending towards north बोल सकते हैं, ठीक है, that's perfectly fine, you can say, right? But when you say June, you are ultimately also saying that in the northern hemisphere it is summer, and when seen only from northern hemisphere perspective, they are moving towards pole, है ना? And in the southern hemisphere, in the June, it is winter, and they are bending. So it depends on how UPSC creates the question, and if your fundamental logic is right. For example, if UPSC create this question also, ठीक है, मान लो they are asking in the month of June which direction is the isotherm bending. Now what you have learned from that, you can conclude the same thing, है ना? तो वहां पे वो चार ऑप्शन देंगे आपको, नॉर्थ, साउथ, इक्वेटर वर्ड, पोलवर्ड. अब आपको अप्लाई करना है कि अगर सारा आइसोथर्म देखा तो किधर जा रहा है. इज दैट ओके? बिकॉज इफ दे आर आस्किंग इन जून ऑन द होल अर्थ, ये तो हमने पढ़ा ही नहीं था, लिखा भी नहीं है, बट अगर लॉजिक समझ में आ गया, इसीलिए मैंने ये सारा काम आपसे कराया ताकि आप मुझे ब्लेम ना कर सको. ठीक है, राइट? यही आपको ब्यूरोक्रेट बन के करना है, कुछ काम खुद नहीं करना है. सारा काम दूसरों से कराना है, पेपर पे उनका साइन होना चाहिए. ठीक है, अपना साइन कम से कम करना है. इसीलिए इंडिया में फाइल कभी मूव नहीं करती है, क्योंकि सारा ब्यूरोक्रेट ऐसे ही पढ़े है. ऑलराइट, किडिंग. समझ में आ गया? लॉजिक इज क्लियर? गुड. सो राइट, सो व्हाट वर वी राइटिंग? That in the southern hemisphere, because of more continentality, the isotherms are relatively more parallel. Is that okay? ठीक. More maritime. यार एक सेकंड होल्ड करो, कौन पढ़ेगा? आप पढ़ो. रीड. बस ठीक है, परफेक्टली फाइन. ठीक है, यही चाहिए था ना हमें भी. ऑलराइट, परफेक्ट. नाउ द नेक्स्ट क्वेश्चन, एंड देन गो ऑन इंटरचेंजिंग दोस मंथ्स एंड ऑल एंड कीप डूइंग दैट एक्सरसाइज. ये आपका अपना एक्सरसाइज है, ठीक है? दिस इज वेयर यू हैव टू अप्लाई योर लॉजिक एंड थिंक व्हाट मोर क्वेश्चंस दे कैन क्रिएट. ऐसा नहीं कि जो कॉपी में लिख दिया बस उतना पे रुक गया, देन यू डोंट क्लियर दिस एग्जाम. यू क्लियर द एग्जाम बाय थिंकिंग व्हाट अदर क्वेश्चंस कैन दे क्रिएट, कैन आई आंसर दैट क्वेश्चन और नो. ठीक है, तो वो सब अब ऑब्वियसली हम क्लास में नहीं करेंगे, बिकॉज आई हैव गिवन यू द बेसिक फंडामेंटल लॉजिक, फ्रॉम दैट यू विल गेट द आंसर टू एनीथिंग. वो आपसे किसी भी मंथ में कहीं पे भी पूछेंगे, आप आंसर कर सकते हो. नाउ लेट मी आस्क यू द सेम वेज. इफ आई आस्क यू विच इज द बिगेस्ट कॉन्टिनेंट ऑन द अर्थ ज्योग्राफिकली? यूरेशिया, नॉट एशिया. वो पॉलिटिकल है, हाँ? यूरोप और एशिया का डिवीजन ब्रॉडली पॉलिटिकल है. वो जियोलॉजिकल भी है, बट ज्योग्राफी का टर्म में वो यूरेशिया है, राइट? सो विच इज द बिगेस्ट कॉन्टिनेंट, एंड हेंस वेयर शुड आई फाइंड मैक्सिमम कॉन्टिनेंटैलिटी, एंड हेंस वेयर शुड आई फाइंड मैक्सिमम बेंडिंग ऑफ द आइसोथर्म्स. दैट्स इट. ठीक है, तो ये क्वेश्चन हो सकता है दैट ऑन विच कॉन्टिनेंट शुड वी एक्सपेक्ट मैक्सिमम बेंडिंग ऑफ द आइसोथर्म. द आंसर इज यूरेशिया. ठीक है, एंड विच इज द स्मॉलेस्ट कॉन्टिनेंट? सो वेयर शुड वी एक्सपेक्ट मिनिमम? ऑस्ट्रेलिया. और वो है भी बेचारा सदर्न हेमिस्फीयर में, दोनों तरफ से थप्पड़. ठीक है, छोटा भी है और ओशियन से घिरा भी है. ठीक है, डू वी गेट इट? राइट. नाउ लेट मी आस्क यू अनदर थिंग, एंड आई नो दिस आंसर मोस्टली विल गिव मी रॉन्ग. है ना, आउट ऑफ माई एक्सपीरियंस. वाई? बिकॉज वी आर ट्रॉपिकल पीपल एंड दैट्स अ हिंट. ठीक है. सो है ना, मैंने आपको बोला है क्लास में ध्यान से सुनते रहोगे तो सब कुछ मिलता रहेगा, बट थोड़ा ध्यान से सुनना है. सो व्हाट डू यू थिंक इज द एवरेज टेम्परेचर ऑफ द अर्थ? हमने कभी बात किया है? व्हाट इज द एवरेज टेम्परेचर ऑफ द अर्थ? 17 डिग्री, 15 डिग्री. 17 मतलब आपने क्लाइमेट चेंज मान लिया है ना सर, ऑलरेडी फैक्टर्ड इन हो गया 2 डिग्री का इंक्रीज. अब हम उसके बाद बात कर रहे हैं, है ना, क्योंकि हम तो सुधरेंगे नहीं सर. तो हम तो 17 से चल रहे हैं सर आजकल. ठीक है, तो ठीक है, मतलब समथिंग लाइक 15 पॉइंट सम डिग्रीज. सो ब्रॉडली फॉर आवर क्लास पर्पस वी वुड से the average temperature. If you don't know, I think I might have said at some point, but if I have not, you have to write this. The average temperature of the earth is around 15 degree Celsius. ठीक है, 15 point something है, but वो 15 चलेगा. Average temperature of the earth, right? Not considering the global warming effect, right? 15 degree Celsius. Now, if I ask you, out of summer and winter, what do we experience more extreme on the earth? Earth मैंने बोला है, ये ध्यान रखना. What do we experience more extreme, and how do you consider or calculate whether what is more extreme? By measuring it with respect to the extreme temperature. So now answer me. What do we experience more extreme on the earth? Winter or summer? Huh? I'm not asking of hemisphere, my question is earth. What do we experience more extreme on earth? Huh? यार मैं बार बार बोल रहा हूं अर्थ और आप पोल की तरफ. यही तो ट्रॉपिकल मैंने बोला था ना. क्या बोला था? यू आर ट्रॉपिकल पीपल. हम जाना ही नहीं चाहते पोल की तरफ. हम पोल को दूसरा प्लैनेट मानते हैं. पोल तो मतलब कहीं और ही है ना. स्पेस एक्स को बोलेंगे एक मिशन करो, सेंड अ रॉकेट टू पोल, है ना. व्हाट इज माय क्वेश्चन? अर्थ. तो पोल उसका पार्ट है या नहीं है? सो वेयर डू यू व्हाट डू यू एक्सपीरियंस मोर एक्सट्रीम ऑन अर्थ? विंटर और समर? ठीक है, मतलब स्टिल आई शुड से दिस इज वन ऑफ द बेस्ट क्लासेस दैट आई हैव एवर फाउंड. ठीक है, क्योंकि ज्यादातर क्लास में इसका आंसर क्या आता है? समर. बट इतना सारा हिंट दिया उसके बाद भी हम पोल को छोड़ने को तैयार नहीं थे. ठीक है, ठीक है. मिडिल क्लास मेंटालिटी, ज्यादा दूर सोचते ही नहीं है. लाइफ में बड़ा क्या बनना है? आईएएस. मतलब वो चाय बेच करके क्या बने हो और आप आईएएस का बियॉन्ड सोचते नहीं हो यार. ठीक है, थोड़ा बड़ा सोचना है लाइफ में. ऐसा छोटा मोटा गोल नहीं रखना है कभी कभी. ऐसा नहीं कि आईएएस मतलब छोटा गोल है, ठीक है, बट ड्रीम बिग. अब्दुल कलाम जी ने भी यही बोला, आपका पीएम जी ने भी यही बोला, हमारा पीएम जी ने. ठीक है. और आजकल पॉलिटिकली बहुत करेक्ट होना पड़ता है, नहीं तो लोग पप्पू बुला देते हैं. ठीक है. सो क्या बुला देते हैं? नहीं नहीं, गाना वाना नहीं गाना है क्लास. ठीक है. सो एनीवेज, कमिंग बैक. सो व्हाट वाज माय क्वेश्चन? व्हाट डू यू फील मोर एक्सट्रीम ऑन द अर्थ? विंटर्स. ऑलराइट. So if you experience winter more extremely, okay, where do you think we experience winters more extreme? Which hemisphere? Northern hemisphere or southern hemisphere? Where in the northern hemisphere? Which continent? Continent पूछा मैंने. upper continent कौन सा होता है? यार मतलब आप थोड़ा तो ट्रॉपिक क्रॉस करो. पूरा अर्थ को अपना समझना है. यस, यूरेशिया. सो फर्स्ट थिंग यू टोल्ड मी, सर, इन यूरेशिया वी शुड एक्सपीरियंस मैक्सिमम बेंडिंग ऑफ द आइसोथर्म. नाउ माय क्वेश्चन इज, इन विच सीजन? इन यूरेशिया, इन विच सीजन शुड वी एक्सपीरियंस मोस्ट आइसोथर्म बेंडिंग? winter. Which month? Which month is this? December. अब ये भी लिख लेना है, सारे आंसर आप ही के, ठीक है. So once you understand, then we write. So अभी पहले क्या लिखा है? Can you read me the last line, dear? आप पढ़ दो. All of you, yes. उसका ऊपर वाला? Bending of the isotherm is maximum in Eurasia. यहाँ तक लिख चुके हैं ना? Very good. So we have already written that the biggest continent, Eurasia, will have maximum bending. ठीक है? And now the next thing, write down that the most extreme season, the most extreme season that we feel on Earth is winters. Most extreme season that we feel on Earth is winters. Okay. Because अब ये क्यों लिखा है, इसका एक रीजन भी लिखना है. Because the average temperature is 15 degree. Hottest temperature on Earth is less than 60 degree. Hottest temperature on Earth is less than 60 degree. तो कितना वेरिएशन है एवरेज से? 45 डिग्री, right? So 45 degrees more. Maximum temperature on Earth is less than 60 degree, which means 45 degrees more. And the minimum temperature on Earth is nearly minus 90 degree. The minimum temperature measured on Earth is nearly minus 90 degree. How much far is that from the average? कितना वेरिएशन है? 105 degrees from the average. वो भी लिखना है, right? Less by 105 degrees from the average. 15 से minus 90 कितना हो गया? 105 हो गया ना, ठीक है. 105 degrees less than average, ठीक है. That's why winters are more severe on Earth, ठीक है. If you see the whole Earth, we find more severe winter than summer. Is that okay? Very good. Hence maximum isotherm bending also happens during winters. Full stop. Out of the habitated continents, which is the continent on which we don't have a habitation? Antarctic. So we are not talking here of Antarctic, right? Out of the habitated continents, Eurasia experiences the coldest winters. And hence isotherms also bend maximum. In Eurasia during winters. What is the month? December, January. ठीक है, this during December, January. अगर and if you see otherwise, Antarctica gets, because that minus 90 degree, minus 89 point some degree that we have measured was measured on Antarctica. But even on Eurasia, we have measured something like, when you go to Siberian regions and all, we have already measured something like minus 80-85 degrees, which is again at least minus 95 degrees away from average. ठीक है, तो यूरेशिया के ऊपर हमने 90-95 डिग्री का वेरिएशन देखा है एंड अंटार्कटिका में 105. ठीक है, तो सब में देखें तो अंटार्कटिका में है, बट हैबिटेटेड में देखें तो भी यूरेशिया पे ही है. ठीक है, Is this okay? Because Eurasia region only we have seen the highest temperature also, and here only we have seen the lowest temperatures also. Okay, in Saudi Arabia and all we find some of the highest temperatures, Libya, Saudi Arabia, so Africa and Asia wala part, and the coldest also we find in Asia only. Okay, very good. So do we understand this isotherm wala story? So if we have to conclude now, right, out of questions, should I ask you, ताकि इसको जल्दी से conclude करें और आगे बढ़ें. So if I ask you, what is an isotherm? They connect the same temperature line. ठीक है, perfectly fine. Second, maritime effect makes them more parallel, and continentality effect makes them more bend towards summer hemisphere and winter season towards equator. Is this okay? Which continent has maximum bending? Eurasia. Which season? Which month? December. Is that okay? That's it. इतना ही है. कहानी खत्म. All right. So this is your whole isotherm thing. Now with this understanding, when you look into the isotherms of the world, ठीक है? ऐसा. So you can see here. This is the month of January. ये दिख रहा है? ये आपका NCERT का डायग्राम है. So if you see both the hemisphere, where is the isotherm bending more? Northern hemisphere. You can see, and in the southern hemisphere it is relatively parallel. दिख रहा है? और यहाँ पे it is bending more. And an isotherm which was supposed to be at this height, how much has it bent? क्योंकि winter के अंदर वो equator word आता है ना? So this isotherm which was supposed to be somewhere here has bent by this much amount and come almost to the top of India. क्योंकि हमारा Himalayan region में भी वही temperature हो जाता है, extremely cold. Do we get it? So this is the maximum bending. And then when you go to the summer season, there also you find the bending, but the bending is something which was supposed to be at this height goes up. इस height का जो water bodies है, यहाँ का isotherm has gone that much high in Siberia. ठीक है? Can you see that? So ये आपका variation है, and in the southern hemisphere it is still relatively parallel. Is that okay? So logic हमें समझ में आ गया. Can we go beyond? Very good. So once we understand this, the next thing that we come to is temperature range, which is something that we have already slightly talked about. अभी बात किया हमने, but we have to slightly get deeper into it. ठीक है? तो वो भी जल्दी से complete करते हैं. Then we have to come to temperature inversion. But before inversion, I'll give you a break. This temperature range thing is a very small topic. हम 5 मिनट में complete करके break ले लेंगे. Is that okay? So let us take this next topic, temperature range. ठीक है? Temperature range. And let us complete this. All right, temperature range. So let us complete this and then go beyond. So when we talk of temperature range, हाँ जी बताइए. Summers में isotherms, wait. Summers में isotherms bend towards. Did we learn that? Which then you're talking of a particular hemisphere. So you have to say that. So summers में in northern hemisphere the isotherms bend towards north. January diagram? अच्छा नहीं, wait. ये वाला July diagram? Northern hemisphere का summer तो ये है, because this is the July diagram. दिख रहा है July diagram, and this is northern hemisphere summer where the isotherms are bending on the continent towards north. In the southern hemisphere, what season should it be? हाँ, अच्छा, so let me come to this January diagram. ये लीजिए. हाँ जी बताइए. अब हेमिस्फीयर बोलो पहले. कौन सा हेमिस्फीयर? Northern hemisphere. Northern hemisphere, January, winter, so it should bend towards equator. That's perfectly fine. हाँ, continent में कहाँ bend हो रहा है? Ocean पे मत देखो. ये continent है. ये जो आइसोथर्म ओशियन में यहाँ पे है वो कॉन्टिनेंट में किधर बेंड हुआ? इक्वेटर की तरफ। ठीक है, क्लियर है? ओके, सो शुड वी कम टू टेम्परेचर रेंज? देखो ये, एंड वन मोर थिंग, because of this question raised by the student, I would say there is one more thing that we have to keep in mind. What? The diagram that we had drawn were pretty symmetrical diagrams, model diagrams, but the continents are not that model continents. वो symmetrical नहीं है ना? तो वो जो bending है, that would also not be very symmetrical. So you have to see the trend there rather than exact bending. क्योंकि कॉन्टिनेंट का शेप तो एसिमेट्रिकल है ना, रैंडम शेप कॉन्टिनेंट्स है ना, वो जियोमेट्रिकल शेप्स नहीं है. तो प्रॉपर बेंडिंग, बस ये देखो बेंडिंग हो रहा किधर रहा है, रादर देन कि यू नो एग्जैक्टली. एंड इन दीज डायग्राम्स दे आर आल्सो एडिंग द इफेक्ट ऑफ, फॉर एग्जांपल, माउंटेन्स. जब आप साउथ अमेरिकन कोस्ट पे जाओगे तो वहां दिखेगा दे आर बेंडिंग मोर बिकॉज ऑफ दैट माउंटेन इफेक्ट. ठीक है, तो वहां पे वो आइसोथर्म माउंटेन के साथ साथ ऊपर चला जाता है क्योंकि वो ओशियन लेवल पे तो रहता नहीं है. यू गेट इट? सो अदर फैक्टर्स वुड आल्सो एड अप टू दिस. इज दिस ओके? बट ब्रॉडली व्हाट वी हैव लर्नड इज फुल प्रूफ. डोंट वरी, मतलब उसका कोई एक्सेप्शन नहीं है. टेक दिस फ्रॉम मी. अगर हो जाए तो मेरे पास वापस आ जाना. फिर भी मैं कुछ ज्यादा कर नहीं पाऊंगा क्योंकि आप एग्जाम दे चुके होगे, बट स्टिल बट आई हैव नेवर सीन दिस हैपन, क्योंकि है ही नहीं इसका कोई एक्सेप्शन रूल में. ठीक है, तो इसीलिए मतलब एज फार एज आई नो आई कैन गारंटी दिस मच. ऑलराइट, शुड वी गो बियॉन्ड? राइट. सो व्हाट डू वी मीन बाय टेम्परेचर रेंज? टेम्परेचर रेंज का मतलब क्या होता है? रेंज का मतलब क्या होता है? रेंज मीन्स व्हेन हाउ मच यू आर डेविएटिंग फ्रॉम द एवरेज. ठीक है, वॉट एवर इज द एवरेज, हाउ मच यू आर डेविएटिंग. राइट, परफेक्टली फाइन. सो व्हाट इज द एवरेज ऑफ द अर्थ? वी हैव रिटन, अभी लिखा था इधर पहले, 15 degrees. And what is the range that we have seen? वो भी हमने थोड़ा देर पहले देखा, that in the summer the range is up to 60 degree and in the winter the range is up to minus 80 degrees. ठीक है, but then we have to minus 90 degrees. So but then we also have to see that which range are we talking of? Are we talking of the range in the day or are we talking of the range in a year? क्योंकि दो टाइप का रेंज हो सकता है. Right? What is the maximum and minimum observed at a place in a day? हो सकता है ना कि एक दिन में कितना वेरिएशन हो सकता है. विच प्लेस ऑन अर्थ हैज मैक्सिमम वेरिएशन इन अ 24 आवर साइकिल? ठीक है, एंड विच रीजन ऑन द अर्थ हैज मिनिमम वेरिएशन इन अ 24 आवर साइकिल? ठीक है, सो वी कॉल दिस एज डायरनल रेंज. डायरनल मतलब दिन का रेंज. राइट, एंड देन देयर इज अ एनुअल रेंज आल्सो. एनुअल रेंज मींस व्हाट? इन अ ईयर विच प्लेस हैज maximum range and which place has minimum range. So we call that as annual range. So एक range हो गया diurnal and the second range is annual. Now in the diurnal range we take the temperature that you normally see in your phones. आपका फोन में टेम्परेचर आता रहता है ना, so diurnal range में हम वो मेजर करते हैं. ठीक है, in annual range we don't measure this. We take the average of the hottest month and the average of the coldest month. Average का मतलब क्या है? All the temperature of the day, all the days of the month will be added and summed and average taken. For example, in December month, जैसा अभी गुजरा पीछे, so maybe in December month at some place the temperature might have touched 0. So that is their diurnal minimum. But when you will take the December average of that place, it will not be 0. It will be something like 5, 7 or 10 degrees. Why? Because that is the month's average and that month has the lowest average. तो annual range में हम कौन सा टेम्परेचर लेते हैं? Month's average. ठीक है, और diurnal range में days average. It is like your expenditure. जैसे आपका घर का मंथली एक्सपेंडिचर कितना है और आपका किसी एक बाई पे कितना एक्सपेंडिचर है. जैसा हो सकता है ना कि आपने अपना घर में सबसे महंगा कोई चीज खरीदा, तो मैंने इस महीने में मेरा बाइंग का रेंज था, मैंने सबसे महंगा चीज खरीदा 10,000 रुपए का एंड सबसे सस्ता चीज खरीदा 1 रुपीज का. सो दैट इज योर सबसे सस्ता सबसे महंगा. एंड मंथ का एवरेज क्या है कि मैंने ऑन एन एवरेज इतना रुपए का चीजें खरीदा. Is that okay? Clear? So temperature range can be both diurnal and annual. Diurnal and annual. Is this okay? Clear? So now when we talk of this diurnal and annual range, what is important here? Diurnal range, which, so again maximum diurnal range and minimum diurnal range, and same ways we'll see for annual range also. Okay? So maximum diurnal range, where do we experience? We experience it in the tropical deserts. Tropical deserts, which means you might ask me a question, sir, do we have other deserts also? We have. We'll talk of that later. Okay? So where do we experience? Like the Thar desert in India. In India, some of the highest ranges we'll find in Thar desert. Annual range. Okay? Why? Because अब वहाँ temperature factor पे जाओ, it has a dry soil, है ना? तो इतना dry होता है sand that it heats up very fast and it also cools down very fast. ठीक है? So maybe the night temperature might be something like 47 degree and day temperature, right? And the night temperature might be something like 21 degree, right? So same place in the day will be very hot and in the night it might become pleasant. Do we get it? Right? So this is what you call as the range. And when do you measure the highest temperature of the day and the coldest temperature of the day? सबसे highest temperature हम measure कब करते हैं? What do you think? कितने बजे होना चाहिए? 12, है ना? But होता नहीं है. Right? It takes another 2 hours, 2.5 hours for the ground to become hottest. It is something like if you take a tawa and put it on a burning fire, the moment you put it, it doesn't become hot. It takes some time to become hot, right? So same thing happens with the land also. It takes some time. So somewhere around 2:30, 2 to 2:30, we measure the highest temperature of the day. Okay? And when do we measure the lowest temperature of the day? Just before the first sunlight comes. Sunlight, not sun. Okay? Just before the first sunlight comes. So somewhere around 3:34 is the time when we measure the lowest temperature of the day. ठीक है? आप अपना फोन में भी देखेंगे तो आपको वैसा ही दिखेगा. When you check the range, the hottest is somewhere around 2:30 and the coldest is somewhere around early morning 3, 4, 5 maximum. Winters में वो 5 तक होगा क्योंकि sunlight late आता है. Is that okay? Clear? So this is how we measure. Alright? So let us write. So when we talk of the maximum, we find it in the tropical desert, maximum diurnal range, tropical desert, and the range will be something like 20 degrees. So within a day temperature might change by 20 degrees. That's a very big range. ठीक है? Within a day temperature might change by up to 20 degrees between the hottest and the coldest. ठीक है? So tropical desert change by 20 degrees or more. ठीक है? And very wide temperature variation is not good for body because we are not able to withstand it easily. आपने सुना होगा ना, older people at home they tell you आजकल temperature change बहुत ज़्यादा है, जल्दी से गर्मी सर्दी होता है, उसी को हम बोलते हैं गर्म सर्द लगना, है ना? You are affected by the cold and the hot parts of the day. That's why what do your grandparents tell you? ऐसे अभी का time है. So in the day you start feeling hot and you come down to, t-shirts. And in the night, early morning, you still feel cold. But if you go on wearing that same t-shirt till night and early morning, what will happen? Gradually, अभी तो young है, आपको पता नहीं चल रहा है. But old age people, they start feeling that in the bones. So they ask you to cover your body. सुना है ऐसा? है ना? Keep covered your body. Now where do you see this? Go to Rajasthan and see those people. Around the year, throughout the day, they keep their whole body covered. Right? Who are the people living in those deserts? Tribes. And you see their clothes. Those tribes will have from head to toe covered throughout the day. No matter how hot, no matter how cold. Right? वो head भी wrap करके रखते हैं. So that during the summer time, they don't feel that temperature variation. So they maintain their body temperature. You get it? Why? Because the variation is very high. That can affect. In the long run, it affects. So that is something that they generally do. And it's not only in Rajasthan. You go anywhere in the desert in any part of the world. You go to Saudi Arabia, what is their usual clothing? दे हैव अ हेड कवर. आपने कभी सोचा वो क्यों जबरदस्ती ऐसा हेड कवर करके रखते हैं? इतना गर्मी में रहते हैं यार. आप यहाँ पे नॉर्मल भी घूम रहे हैं तो पूरा सर्वर खोल करके, है ना, बनियान पहन के घूम रहे हैं, और वो फुल स्लीव. अरे समझ में, राइट? So this is how culture develops. I told you, right? Culture develops from geography of the region. Is that okay? Good. So maximum temperature and minimum temperature, where do you find? You find it in the equatorial islands. Equatorial islands. In the equatorial islands, we find minimum temperature. The range might be 2 to 3 degrees within the day. Maximum 2 to 3 degrees. So if the daytime is something like 33 degree, the night time will be something like 31 degree. ठीक है. और if the day is 30 degree, night might be 27 degrees. Only 2 to 3 degree variation. उससे ज़्यादा variation नहीं होता है. Is that okay? Do we get it? Right? So this kind of variation you find in the equatorial islands. So diurnal range is very less there. So whether it is day or night, you will feel the same temperature. There you can easily go around in a t-shirt. ठीक है, क्योंकि रेंज ही ज़्यादा नहीं है. Is that okay? Right? That's why when you see the tribes of Andaman Nicobar, right, especially the Nicobaris and all, वो ज़्यादा कुछ अपने आप को cover नहीं करते हैं. Around the year, they are just wrapping around their, you know, lower part something, and that's it, or upper part something, and that's it. They won't cover the body much because the temperature doesn't vary too much and it is warm. Right? Now compare their clothing with the clothing of Rajasthan or Saudi Arabia and all, and Africa, Sahara. You will understand the difference. अरे समझो, वो भी ट्राइबल है, ये भी ट्राइबल है, दोनों के पास इक्वली है. Okay? Okay, good enough. Now let us come to annual range. So when you talk of annual range, again maximum and minimum. So which is the annual maximum? You find it in places. Where do we find annual maximum? Annual maximum we find in places such as your Siberian region, Central Asia, Siberian region. Those regions we find some of the maximum annual range. Why? Because in winter that place might go down to as low as minus 45, minus 50 degree annual. And in the summer the same place might come to 10 degrees or 5 degrees. Okay, so what is the range? Minus 45 से 50 degree का range है. That's a very high annual range. ठीक है, एनुअल रेंज जो आप मैक्सिमम डे में फील करते हो उतना वो एनुअली फील करते हैं. ठीक है, एंड देयर एक्सट्रीम वुड बी मच लोअर एंड एट द बोथ एंड्स. ठीक है, इज दिस ओके? राइट? सो यू कैन से द साइबेरियन एंड नॉर्दर्न Central Asia, that region has the maximum annual range of temperature, and minimum annual range is same, equatorial islands. Equatorial islands. ठीक है, equatorial islands. Is this clear? So maximum range, minimum range, do we understand this? Is this broadly clear to us? So temperature range समझ में आ गया. Now we have to come to next topic. कौन सा है? Temperature inversion. But before that I'll give you a break. And there is one more small thing that I would like to talk to you. We do go on talking, you know, हम आपस में मजाक करते रहते हैं. But always keep this one thing in your mind till you get selected. Right? And this is the most important thing for your part. No matter what happens outside, no matter who says what, till you get selected, don't incline yourself to any side in terms of politics. आपके आंसर में थोड़ा भी रिफ्लेक्ट हो गया कोई सा भी साइड, ठीक है, तो आपका नंबर कम हो जाएगा. सो टिल यू गेट सिलेक्टेड, राइट, नो मैटर योर फैमिली इज ऑन व्हाट साइड एंड यू इंटरनली आर ऑन व्हाट साइड, डजंट मैटर, बट इट शुड नॉट शो इन योर आंसर्स इन एनी वे, किसी भी साइड. ठीक है, सो रिमेन न्यूट्रल इन योर आंसर्स 100%. And neutral means what is the language? NCERT. ठीक है, so write in the language of NCERT and follow your constitution. ठीक है, जैसे आजकल हम बहुत जगह सुनते हैं ना, ये वाला इंक्लिनेशन कोई रिलीजन की तरफ है, कोई किधर है, कोई सेक्युलर को बुरा बोलता है, कोई यू नो सारे रिलीजन को और रिलीजन को सपोर्ट करने को बुरा बोलता है। हमारा कॉन्स्टिट्यूशन दोनों करता है। ठीक है, हमारा नाम के अंदर ही सेक्युलरिज्म है और हमारा रिलीजन, हमारा कॉन्स्टिट्यूशन सारे रिलीजन्स को इक्वली सपोर्ट करता है, किसी भी को भी कम नहीं करता है। ठीक है, तो हिंदुइज्म को भी उतना ही सपोर्ट करता है जितना दूसरे को करता है। एंड योर आंसर शुड ऑल्सो शो ऑल दिस। सो ये चीज ना आपको एग्जाम में अपने अंदर एग्जाम तक बना के रखना है, उसके बाद जो करना है करते रहो, मुझे फर्क नहीं पड़ता। राइट, बट तब तक राइट, सो प्लीज डोंट बेंड ऑन एनी साइड बिकॉज ऑफ एनी डिस्कशन हैपनिंग एनीवेयर। ठीक है, क्लास में भी अगर हम बोलें कि नहीं नहीं उल्टा है तो नहीं सुनना है, किसी का भी बात नहीं सुनना है, आपको सिर्फ कॉन्स्टिट्यूशन का सुनना है और एनसीईआरटी का सुनना है, क्योंकि वही आपको एग्जाम पार कराएगा। इज दैट क्लियर? ठीक है, दैट्स इट। टेक अ ब्रेक, कम बैक इन 10 minutes and then we go to the next topic. Sir, anything online you want me to take up? Right, so now let us start from the next topic, which is temperature inversion. All right, so temperature inversion. So when we say temperature inversion, what do we mean? First we have to understand, so इसका थोड़ा basic समझते हैं पहले, then we'll go. So let me ask you a few questions. Inversion का मतलब क्या होता है? If anything, is turned upside down, so opposite of what is normal, so that is something like inversion. So when you say temperature inversion, what should it mean? That the temperature trend should be inverted. Is this okay? So temperature inversion में होना क्या चाहिए? A normal temperature trend should get inverted. And which region are we talking of? In temperature inversion, we talk of the atmosphere's vertical temperature variation. ठीक है? Atmosphere's vertical temperature inversion. So what is the normal trend of temperature in the atmosphere vertically? As you go to higher altitudes, the temperature decreases. है ना? Decrease. Everyone agrees? ठीक है? So in inversion, if I say temperature inversion happens in this region, then what should happen? As you go higher, the temperature will start increasing. And is this natural? Whatever we have learned out of this, is it natural or it should be something special? Special, क्योंकि naturally क्या होता है? Temperature should decrease, but this is what temperature inversion is all about, right? Temperature inversion is the special case in the atmosphere where the temperature starts to increase as you go higher. Is that okay? So in very simple term, this is what temperature inversion is, right? Now, if we draw and try to show, so I'll just first of all draw the temperature graph for inversion to make you understand. So suppose this side the temperature is increasing, and I would expect you to draw yourself also temperature. Okay, and let us say this side we have the altitude. So what should be the normal temperature graph like? Right, this is the normal lapse rate. Everyone agrees? This is your normal lapse rate, which means as you go higher from the surface, and suppose this is the surface and that's the altitude, as you go higher, the temperature decreases. But in temperature inversion, something reverse will happen. What will happen? As you go higher with altitude, the temperature will increase. So this is the graph of temperature inversion. This is temperature inversion. Okay? So this is the normal lapse rate graph and this is the temperature inversion graph. So as you go higher, the temperature will increase. Clear? Okay. So you can draw this and you can write that we see in this diagram the normal lapse rate diagram and also the temperature inversion. Okay, everyone drawn? Very good. So now once you understand what is temperature inversion, so simply said, as we go higher with altitude, as we go higher in altitude, the temperature normally tends to reduce. As per normal lapse rate. Normally tends to reduce as per normal lapse rate. Full stop. On the other hand, temperature inversion means those special circumstances when the temperature tends to increase, with altitude. Full stop. Okay. So next subheading, what are these special circumstances? Of temperature inversion? What are these special circumstances of temperature inversion? So we have different types of inversions. Different circumstances of inversion, such as radiation inversion. You write down the names. There are 4 of them. Okay. There are 4 such special circumstances. 1, radiation inversion. Okay. Second, subsidence inversion. Third, marine inversion. And fourth, frontal inversion. Right, as discussed one by one below. So we'll take all of them one by one. Right. Just before that, I saw a question on the screen. I think was some miss ho gaya. Sir, what about the isotherm bending when Earth is in the equinox position? What do you think? In equinox, are we having summer or winter? Equinox. Summer or winter or in between? Okay. When do we have maximum bending? During summer or winter? है ना? So when we are in between, the bending should be maximum or minimum? Minimum, nearly minimum. The whole Earth will generally have neither summer nor winter. It will either have autumn or spring. So in that season, in the equinox, we'll generally see one of the least bending of the isotherms on the whole Earth, whether continent or ocean. Ocean पे तो anyways होता नहीं है, and even on continent you will not see much bending during equinox. ठीक है? So the question was there, so we are answering that. Is that okay? Clear? So on the continent, in which period will we see minimum bending? Neither summer nor winter, because that's when we'll see more bending. When will we see minimum bending? During the equinox on the continent. Is that okay? Right? So now let's come back to the first one, what we call as radiation inversion. ठीक है? So what is radiation inversion? It takes place first of all where? It takes place in or over plains. It takes place over plains. Okay? Takes place over plains. So we have the radiation, then the subsidence, then the marine inversion, and then the, did I say the last का दोनों बोला था ना, marine inversion and frontal inversion? ठीक है. So it takes, the radiation inversion takes place over planes. So how? Let us see. So suppose this is the, and please draw with me. So suppose this is the surface of the earth, and this is the tropopause. Alright, earth surface and tropopause. So what will happen? When do we get the radiation inversion? Conditions, uska conditions bhi likhenge. Conditions. It happens during winter nights. Winter night is the first condition for radiation inversion. Winter night. In the plains during winter night. Okay. So in the winter night, what will happen in the plains? The land will go on radiating heat due to its general character. We have learned, irrespective of its temperature, land radiates, or surfaces radiate heat. So the land will go on radiating heat. Okay? Because of this radiation of heat, because the heat is coming from the surface will become relatively warmer or colder. The surface from which heat is coming itself, it will become colder. Therefore this surface becomes colder. So surface turns, surface is cooled. And if the surface is cooled, what will happen to the air which is in contact with the surface? The air in contact with the surface will also become relatively cooler. I hope you understand this. So this air in contact with the surface also becomes relatively cooler. Right? This surface which was in contact with the air becomes cooler because the surface is cold. Whereas the air above it will remain relatively. Why? Because it is not in contact with the surface. Okay? So just assume, first assume and understand. Let us say earlier, by the evening, not in the night but evening, before that night, the surface temperature was, let us say, 10 degrees and this layer was something like 8 degrees. Above it, it was 6 degrees, above it, it was 4 degrees, 2 degrees, 0 degree, something like this. In the night, due to this radiation and all, the surface became 0 degree. Okay? So we saw that the temperature earlier was something like 8 degrees. पहला क्या क्या था? 8 degree, 6 degree, 4 degree, 2 degree, 0 degree. And now that the surface itself has become 0 degree, this air might become something like 2 degree now. ये वाला 8 से ठंडा होके 2 हो जाएगा. And just above it, the temperature might again, from 6, it might decrease again. ठीक है? And this might become something like 4, ऐसा है ना? So now as you go higher, what is happening to the temperature? The temperature is increasing, at least up to 4. है ना? This was 2, this is 4, this was, and let us say वो जो 4 लिखा है उसको हम 5 लिख देते हैं for the time being, let us say, or 4.5. So 2, 4, 4.5 तक तो increase हो रहा है. After that it is decreasing. ठीक है? Because the upper atmosphere air, it doesn't come in contact with the ground, so that is not affected. But at least this part is affected. ठीक है? So in this region, this much region, what do we experience? यहाँ से यहाँ तक. In this region, this whole region we experience the inversion, and above this the temperature is again normalizing. ठीक है? So this is the region where you experience inversion. And to what height does this normally happen? Up to a height of around 400 meters. ऐसा ओशियन में 400 मीटर नीचे तक आपका फोटिक जोन था, वैसा ही इन्वर्जन भी नॉर्मली अप टू 400 मीटर्स होता है. ठीक है? So from the surface up to 400 meters you might get inversion. Above that you might again become normal. Is that okay? That's why we have drawn, where we have drawn that graph. तो ग्राफ के अंदर भी देखो, only up to a certain height the inversion is taking place. Right? What is the height up to which the inversion is taking place in this graph? Up to 400 meters. So this inversion is taking place up to 400 meters in the graph. and after that you are coming back to normal. Is that okay? Clear? So drawn this inversion wala mein bhi correction kar liya hai thoda, add up, and here have you drawn? So what do we get? Up to a height of 400 meter we get inversion. So the first condition is winter night, and in winter night what is happening? The radiation is going to space. This is the first condition. Then there is another condition which is required, which is, now please see and understand. I hope you remember clouds were able to radiate back or reflect back heat. हमने पढ़ा था. So same ways in the night sky, in such conditions, it is winter night, but let us say there is a lot of cloud. What will the cloud do to the radiation? They might reflect it back to the ground, and if this radiation is reflected back by the clouds, suppose ऐसा करके clouds है, you don't draw that cloud thing. ठीक है, आप मत बनाइए. Let me just make it because I'll rub it. So let us say there are clouds in the sky. So what will these clouds do? They will tend to reflect back the heat, and the heat will come back to the ground, and it will again heat up the surface. ठीक है? So the surface might again get heated. ठीक है? So cloud presence, is it good for inversion or bad for inversion? Bad. So sky should be, that is the second condition. So first condition, winter night. Second condition, clear skies. Clear skies. That's the second condition for inversion. Clear skies. ठीक है? Please go on writing conditions for inversion. ये है, ये लिखा हुआ है यहाँ पे, conditions for inversion. First, winter night. Second, clear skies. ठीक है? Now, thanks to all this, what will gradually happen once this inversion will happen and this lower air becomes cold? यहाँ पे क्या process start होगा? What process might start? It will become cold. So the moisture, water vapor will start condensing, and condensed water vapor will turn into what? It can turn into fog. So you will start getting one fog in that region. और fog का सिवाय और क्या हो सकता है ना? Fog, mist, ये सब होगा. So what all will you start getting? You will get fog or mist, or on the surface ground, what will you start seeing? Very cold night, dew. So dew formation will also start happening on the surface, dew formation on the vegetation and all. So fog, mist, dew, and frost also. Frost is frozen dew. Frost, which is nothing but frozen dew. So that might also happen. So due to inversion, all this will happen. When inversion happens, this will happen on the ground. That you will see fog, mist, dew, and frost. But if the heat comes back and hits the ground, will you get all this? No. So if there was some fog, let us say kuch hua tha, and then clouds came, then what will that do? They will again make the ground hot, and the fog might go away, mist might go away, you know, dew, etc. might evaporate. All right. Do we get it? Clear hai? Right? So now, is there any other condition which is left? Now just imagine everything has happened perfectly fine, no cloud, clear skies, and this region's air has become cold, and let us say there is very strong wind coming from some other region and blowing away all this cold air. सब कुछ बन गया, and then somebody comes and takes away. Then what will happen to the air here? It will again become warm because cold air is taken away. ठीक है? Yes or no? So are strong winds good for inversion? No. So what kind of wind or air status we should have? No wind or very gentle wind. Right? No or very gentle. Both. But strong wind should not be there, because strong wind will carry the whole thing away. Okay? So the third condition is no or very gentle winds. No winds or very gentle winds. Okay? This is something that you observe during fog. When you have a very foggy condition, you generally don't have strong winds, because if it is strong wind, then gradually the fog will be removed. Okay? So no winds or very gentle winds. Is this clear? So समझ में आ गया? So where will we get this kind of what you call as radiation inversion? In the plains where all these conditions are met. And what is the outcome of this? It will create fog, mist, dew, cold air, all this. And when will it dissipate? When the sun will again rise. When the sunlight will be able to come and it will start penetrating that whole thing, then gradually the whole thing will end. Okay, clear? So should we move on to the next one? ये बना लिया है आपने, चलेगा, right? You don't need much dictation. चल जाएगा ना, perfectly fine. Okay, let us say. So now let us come to the second one, which is what you call as subsidence inversion. Okay, so in subsidence inversion, what happens? Subsidence inversion normally happens in this kind of a situation. Okay, so as you can see, you have a mountain and a valley, and on the mountain this white thing is the snow, right? And it is the night time. ठीक है, I'm not writing winter here. यहाँ winter का जरूरत नहीं है, snow है तो summer में भी हो सकता है. Is that okay? Right? So what will happen is, now just think and give me the answer. It's pretty logical. Let us say there is some air in this region, यहाँ पे ऊपर, okay, and okay, कुछ और color use करते हैं, no problem. So let us say, yes, something like this. ऐसा, you have cold, you have air over this, you know, some air is there over this colder snow surface. Then what will happen to that air over a period of time? It will cool down, hence it will become lighter or denser, and hence it will tend to go up or down the slope, and hence it will fill into the valley. So this air will tend to come here and fill up the valley. Why? Because it has become cold, and what will happen to the air which was already in the valley? That might be colder or warmer. Warmer, so warmer, hence it will be lighter. So where will that go? It might be slightly risen up. So now you have warm air above and you have cold air below. ये क्या है? Inversion. यही था ना inversion. So this is called as subsidence inversion or valley inversion. दोनों बोलते हैं इसको. Right? So valley inversion or subsidence inversion. Valley inversion or subsidence inversion. Alright, and in this what happens? Which time? वो सब थोड़ा लिख लो, 2-4 line. Right, so valley inversion or subsidence inversion happens during night time. During night time, when upper part of mountains, during night time, when upper part of mountain have snow cover, upper part of mountain have snow cover, hence air over such region, hence air over such region becomes cold. Air over such region becomes cold and hence dense, and therefore sinks into the valley replacing the lighter warmer valley air, replacing the lighter and warmer valley air, which tends to rise hence causing inversion conditions. Hence causing inversion conditions in the valley. Inversion conditions in the valley. Okay, with colder air in the lower region. Okay. So now if this is happening and there is a lot of fog and frost and all this, will it be good for the crops in that valley? No. Hence generally, so you can write this creates fog and frost in the valley. ये line लिखा हुआ है. Okay, there is this line written wrong in the NCERT that this helps the crops. वो wrong है. ठीक है? So that's why I'm giving you this line. That the fog and the frost created if prolonged is not good for crops in the valley. Okay, hence normally people have their crops relatively higher on the slopes. Have their crops relatively higher on the slope and not in the lower part of valley. Relatively higher on the slopes and not in the lower part of the valley. Right, so they will tend to create their fruit trees and all that in the relatively higher parts, not exactly in the lower part. Okay, that protects it from prolonged frost. Okay, is that okay? Then let us come to the next one. So after this valley inversion and subsidence inversion and radiation inversion, the third one is marine inversion. So अभी तक आपने कहाँ का inversion देखा? Plains में कैसा होगा समझ गए, माउंटेन्स में कैसा होगा वो भी समझ गए. अब क्या बचा? कोस्ट. सो लेट अस सी कोस्ट पे कैसा होता है. राइट, इन्वर्जन इन द कोस्ट्स. सो इन्वर्जन इन द कोस्ट. अच्छा एक और चीज बताओ, इफ दिस इन्वर्जन काइंड ऑफ अ थिंग इज हैपनिंग, राइट, एंड यू हैव कोल्ड एयर बिलो एंड वार्म एयर अबव. ओके, so and let us say in that cold air region there are cities and all, do you think वहां पे if there is some pollution that will tend to rise? हाँ, अगर वो cold air polluted है, if that cold air gets polluted due to dust and all, will it rise? No. So will the pollution go away? This is one reason why urban areas experience more intense pollution during winters, because the air does not rise. Whatever is the polluted air remains low because it is dense, और उसके ऊपर का एयर रिलेटिवली कभी कभार वार्म हो जाता है. ठीक है, सो डेंस एयर कैन नॉट go through lighter air, right? So the dense air, colder air remains low. This is one reason why you get a lot of pollution in cities like Delhi and all, because they are from on the sides they have land only. आया समझ में? ठीक है. So now let us come to marine inversion. Marine inversion. What is marine inversion? Let us see. So marine inversion normally happens during end of winters, starting of summer. That is somewhere around spring. लिखना है. Marine inversion happens around end of winter, start of summer, around spring. End of winter, start of summer, around spring season. So what happens in this is, right, that the land starts to warm up. लिखना है, ये सब लिखते जाओ. It's very simple, you will understand. Land starts to warm up. Though oceans might be relatively cooler. Land starts to warm up, though oceans might remain relatively cooler. Hence, air over land might rise. Air over the land might rise. air over the land might rise and colder denser air from the ocean. So air over the land might rise and colder denser air from over the ocean might come over the land, might come or spread over the land. So this air we are saying, the colder denser air over the ocean might spread over the land, because the land air has become hotter and risen. So land air has risen, so this air might come and fill that region. So ultimately what will you get? इसका वजह से होगा क्या? That this land region will have colder air below and warmer air above near the coast, because the oceanic cold air has come in. So what will this do? Again inversion. This is marine inversion. So colder air from ocean comes and fills up the land surface. ठीक है? So we can write colder air from the ocean comes and fills up. ऐसा कुछ लिखा है ना? Right? So colder air from the ocean comes and fills up the land. Hence inversion over the land. Hence inversion over the land or the coast. Inversion over land or coast, known as marine inversion. So where should we experience the fog now? इसका वजह से fog कहाँ बनेगा? In the coastal region. So coastal regions start experiencing fog due to this. And if you get fog in that coastal region, will it be easy to navigate on the coast? Ships and all? No. This is the difficulty they find. That ships find difficult to navigate during this phase because the coast is not visible. ठीक है? Due to fog on the coast, ships find it difficult to navigate. Alright? Clear? Very good. So that's your marine inversion. Now, which is the fourth inversion? Frontal inversion. है ना? तो लिखिए टॉपिक frontal inversion. Frontal inversion. अच्छा, डायग्राम नहीं बनाया हमने मरीन का? नहीं बनाना है? इच्छा है? यस सर, तो बना लीजिए. ठीक है? So basically I'll just put the arrow also of which air is moving which side. ये थोड़ा ज़्यादा wide arrow हो गया ऐसा. Right? So this colder air is filling that land and the warmer air has risen up. ठीक है? Done? No sir. अभी तो हो गया होगा? नहीं? Okay. So then write down next frontal inversion. अब frontal inversion कर लेते हैं. So written frontal inversion, right? So here also I'll dictate and you just write. It is simple. Right will be covered after fronts. यही लिखना है. मैंने बोला ना सिंपल है. ठीक है? क्या लिखना है? ऐसा क्या देख रहे हो? लिखना है will be covered after fronts. Topic over. That's it. ठीक है? क्योंकि अभी फ्रंट नहीं पढ़ा है तो कैसा समझोगे फ्रंटल इन्वर्जन? तो कब करेंगे? वही लिखा है. बट लिखवाया क्यों? ताकि 1.5 साल बाद जब कॉपी खोलो तो ये ना लगे कि सर ने मिस कर दिया, ठीक है? तो वहां पे पढ़ोगे तो क्या याद आएगा, सर ने लिखा है फ्रंट्स के बाद होगा, नहीं तो आप लोग तो सीधा ब्लेम कर दोगे सर ने पढ़ाया नहीं क्लास में। ठीक है, चलो। सो ओके, so should we move on to the next topic? So with this, temperature part of the story is over. क्या डाउट है? हाँ जी बोल डालो। आएगा, उस सब का सब विजिबिलिटी में आएगा, ठीक है? ऑलराइट, सो जो भी मुझे पढ़ाने का मन नहीं होता मैं बोल देता हूँ, आएगा। आपको क्या पता आएगा नहीं आएगा? ठीक, नहीं नहीं आएगा, ये सीरियसली आएगा, ओके? नहीं तो वो क्लास के बाद मेरे पास आ जाएगा, मुझे भागना भी है, जान बचाना है, सुबह बताया था, है ना? सो आई एम जस्ट थिंकिंग क्लास खत्म हो गई मैं करूंगा क्या? शुड आई गो बैक होम या खा पी के जाना चाहिए? ओके, सो एनीवेज कम बैक, सो लेट अस कम टू, हाँ जी, व्हाट इज टर्बुलेंस इन्वर्जन? व्हाट डिड यू से? हाँ उसके बाद कुछ बोले? अच्छा नहीं, तो सी टर्बुलेंस इन्वर्जन इज अ फिनोमेना दैट यू वी सी नॉर्मली इन द अपर एटमॉस्फेयर, ठीक है? एंड दैट इज नॉर्मली हैपनिंग ड्यू टू, लेट मी से वन थिंग हियर, I have never seen UPSC asking in GS or even in mains as far as I remember any question around this, ठीक है? So I won't take you people into that if you ask me, right? It is a upper atmospheric phenomena where upper atmosphere winds are involved, right? And it is created due to that upper waving that happens on the top of these jet streams and all, somewhere around that region. But should I take you into that? I don't think. तो इसीलिए उसका जरूरत नहीं है करने का, दो सम टीचर्स डू कवर बट आई डोंट थिंक इट इज नीडेड, ठीक है? तो इसीलिए करेंगे नहीं. इफ यू स्टिल वांट कम टू मी आफ्टर द ब्रेक, वील डिस्कस, बट नॉट फॉर द होल क्लास, ओके? आगे करें. सो लेट अस कम टू प्रेशर, ठीक है? सो प्रेशर, व्हाट इज प्रेशर? एटमॉस्फेयर. सो टेम्परेचर पार्ट इज ओवर, ठीक है? आज तो मेरे पास ऐसे भी टाइम है, चिंता ना करो, मुझे घर जाना नहीं है आज, ठीक है? So come again. So let us come to pressure. All right, atmospheric pressure. So what do we mean by atmospheric pressure? Let us see. All right. So when we talk of atmospheric pressure, by the way, what is pressure as you understand right now? Because then there is something wrong in this also that you understand. So it is the force per unit area. So when you say atmospheric pressure, इसका मतलब क्या है? Force of what? Force of air. Why will air put a force? Due to gravity, the air will put pressure on Earth surface. Is this the atmospheric pressure? Yes or no? Why no? जो no बोल रहा है उसको भी आंसर चाहिए मुझे. Why no? अच्छा, ocean surface भी मान लिया. All surfaces of Earth. So the pressure put by the weight of air on all surfaces of Earth. Is that atmospheric pressure? Should we say? Yes or no? अच्छा weight पता है क्या होता है? Weight of something, because some places you read this word weight of air है ना, और weight of air over a region. तो weight of air कैसा डायरेक्शन में एक्ट करता है? In what direction does weight act? Downward. Does pressure act only downward? Atmospheric pressure. So is it weight of air? So it is it weight of that gravitational गैस का, यू नो, द मास इनटू ग्रेविटी ऐसा मल्टीप्लाई करके एरिया से डिवाइड कर दिया, वैसा है? दिस इज समथिंग दैट आई वांट यू टू अंडरस्टैंड हियर, ठीक है? फॉर एग्जांपल, व्हेन यू टॉक ऑफ द प्रेशर पुट बाय अ ग्लास ऑफ वाटर, देन द प्रेशर इज बीइंग पुट ओनली डाउनवर्ड्स, ठीक है? So it will just try to make a hole at the bottom and flow down. But when you talk of pressure of air, air pressure does not act only downward. It acts in all direction. How do you realize this? You try to blow a balloon, right? And you try to fill water into the balloon. When you try to fill water into the balloon will generally try to put more pressure downward and it will try to hang downward. But when you fill air into a balloon, it does not hang. Yes or no? It will not try to hang downward. And the balloon might try to put pressure in all directions and try to crack from any side. Are you समझ में? Another way to understand this, if I put a glass of water and let us say I put water into the glass, right? And then I cover that glass and then I remove that cover, will the water try to come up from the top? But if I do the same thing with air, air will come out in any direction. Why? Because of the pressure. So in what direction does the air pressure work? This is the most important thing that you have to understand with respect to air pressure. Because many times the definition of air pressure is given as weight of the air downward. Right? It is not only the weight of the air, because weight only acts downwards. Whereas air pressure acts in all direction. तो ये यहाँ लिखना है आपको. ठीक है? So please do write. That atmospheric pressure is the pressure of compressed air. It is the pressure of compressed air where or when, you can write both, where or when the compressed air tends to spread and expand. Compressed air tends to spread and expand in all directions. Spread and expand in all directions. And hence, simply said, though the weight acts only downwards, but air pressure tends to act in all direction. Tends to act in all direction at a given point. Alright, so this is a simple thing about atmospheric pressure. Now second, how do we measure atmospheric pressure? Right? So we measure atmospheric pressure using a device. कौन सा device है? Barometer. वो भी लिख लीजिए. Atmospheric pressure is measured using a barometer and normal atmospheric pressure is represented as 1013.2 millibar. 1013.2 millibar. Approximately 1013 is what you remember for your purpose. ठीक है? This is called as normal atmospheric pressure at mean sea level. This is known as normal atmospheric pressure at mean sea level. mean sea level. And in absolute terms, absolute terms, if the pressure is lower than this, if the absolute pressure is lower than this, then we call it as low pressure. Low pressure with respect to normal atmospheric pressure. Is called as lower pressure than normal atmospheric pressure. Whereas if it is higher than this, if it is higher, we call it as high pressure with respect to normal atmospheric pressure. Okay, if it is higher, we call it as high pressure with respect to normal atmospheric pressure. Okay. So what does this mean? This means something like this. Suppose this is your 1013 and any pressure on this side will be called as lower pressure with respect to normal atmospheric pressure, and any pressure on this side will be called as higher atmospheric pressure. Is this okay? Do we get it? ये simple सा चीज है, nothing too complicated. But this pressure definition is of not much use in our day-to-day life. ये definition absolute के term में है, ठीक है, but this is of no use or not much use in our daily life, right? In daily life, what do we mean? Normally in daily life, we have a situation where we will have two pressures, something like this, or maybe something like this, as a. Okay, so one of the values will be that one, the other will be the other blue line. Now, both of them, if you see, are high pressures, but when you talk between them, right, then you will find that out of C and D, if I ask you which is high pressure and what is C? Low pressure. So we generally talk of relative pressure. We generally don't talk in terms of normal atmospheric pressure. Okay? So in our most of our observations, we generally talk with respect to, or most of the phenomena, we generally talk of relative pressure. It is just like you people, you know, आपका क्लास के अंदर किसका कितना नंबर आ रहा है एब्सोल्यूट क्या है उससे फर्क नहीं पड़ता, दोस्त का कितना नंबर आया है ना. सो इफ योर फ्रेंड इज गेटिंग 43% एंड यू आर गेटिंग 48%, यू हैव अ हायर स्कोर, है ना. एंड सेम वे दूसरा टाइप का फ्रेंड्स भी है क्लास में, एक का 92 एक का 98, तो 92 वाला विल हैव अ लोअर स्कोर. सो यू माइट बी हैप्पी इन द क्लास एंड दैट 92% वाला माइट बी सैड. डू यू गेट इट? सो वैसा होता है ना, कि आप अपना हमेशा दोस्त से नंबर कंपेयर करते हैं जिससे आपका मतलब है, ठीक है, राइट राइट. सो सेम वेज हेयर ऑल्सो व्हेन वी टॉक ऑफ प्रेशर कंडीशंस इन डिफरेंट रीजन्स, वी टॉक ऑफ the other pressure condition with which we are comparing. So many times it would happen that this C type of pressure we might say low pressure, and many times this B pressure, which is less than normal pressure, we might say higher pressure. Do we understand? So this is relative pressure, right? So what are we mostly concerned about? Relative pressure. So you can write that line also, that generally we are more concerned about relative pressures. Generally we are more concerned about relative pressure between two regions. Where one will always be a higher pressure and the other will always be lower pressure, irrespective of normal atmospheric pressure. Where one will always be higher and hence the other will be lower. One will always be higher and hence the other will be lower. irrespective of normal atmospheric pressure. Okay. So what do we mean by this? Let us see. So let us understand this high and low pressure wala story. Okay. So what do we mean by high pressure and low pressure? So then write down types of high pressure and low pressure. Types. Okay. Types of high pressure and low pressure. By the way, can you just remind me which are the elements of weather and climate that we did? कल लिखा है हमने. सबसे पहला, second, sunlight. But the sequence that we will follow in the class will be first temperature, then pressure, then winds. ऐसा जाएंगे. ठीक है, जैसा वो बोल रहे थे कल, है ना? क्योंकि आपका बुक में वैसा लिखा हुआ है, तो हम वैसा ही फॉलो करेंगे. And actually, if you see logically also, it's that sequence. ठीक है, so we'll follow how the book goes, right? So पहला अभी क्या किया हमने? Temperature. Right now we are doing. So what should come next? And that will come just now, right? So in addition to pressure, we'll also be doing winds because they are related to each other, right? Pressures give you wind. ठीक है, तो अभी वो भी आने वाला है. That's why I asked. ठीक है, so let us come back. So please see and draw along with me. So what did you write? The types of high pressure and low pressure, which means there are different types of high pressure and low pressure. Please see here. Now let us say we have a region, and let us say this is far away from each other, and you have a warm region here, warmer region, and the other end you have a cooler region, and something like this you have already done earlier in the tropopause. तो ये थोड़ा वैसा ही है कुछ, ठीक है? And this is the, sorry, in the troposphere. So tropopause, right? So in the warmer region, you tell me what should happen to the air, and I need the answer from all of you. Warmer region, what should happen to the, अब देखो अभी तक जितना भी कहानी था, that's okay. अब next 4 minutes please be here. उसके बाद भी हो सकता है 5 मिनट और लग जाए, that's okay. But अभी 4 मिनट तो पूरा ध्यान इधर ही चाहिए मुझे, because I need answers from all of you. आप ही को आंसर देना है, otherwise I won't say anything. मैं बैठा रहूंगा, मैंने आपको पहले ही बोल दिया है, ठीक है? So जाना आपको इस बार, right? So the surface, what should happen to the air which is in this region, the warmer region? Rise सीधा नहीं बोलना है. Give me all the steps. The air will become warm. So this region, the air will become warm, and hence it will become expand. Lighter ऐसे ही हो जाएगा. कुछ भी चीज वार्म करो तो लाइट हो जाता है. घर पे जाओ, पनीर मखानी एकदम गर्म करके खाओ, क्या लाइट फूड हो गया वो? ऐसा नहीं बोलना है. ओके, सो expands, and because of that it becomes lighter. Is that okay? ठीक है, so warm, expand, light, hence rise. ठीक है, so ऐसा. So this warm air tends to rise. Now as this tends to rise, what will it do to the surface? There will be more air here or less air? Less air. Less air means pressure will be more or less? So यहाँ पे क्या pressure create किया इसने? Low pressure. Do you understand why low pressure is created here? So this is the cause why a low pressure is created. And is this created mechanical reason or thermal? Thermal मतलब समझते हो ना, heating cooling. Is it because of heating cooling or is it because of movements? Heating cooling. So this is a low pressure created thermally. T नीचे लिख दिया thermal का, ठीक है? So low pressure. And because of this low pressure, what will the surrounding air try to do? It will try to come. So from the side, air should move in or out. So from the side, air will try to move into this region. Clear है? And vertically the air is moving in or out? Out. Don't give me up. ठीक है, क्या बोलना है? जैसा पहले हम कर रहे थे ना, वो जब मैंने पूछा था नॉर्थ और साउथ और पोल, तो आपने कहीं पे कुछ लोग नॉर्थ बोल रहा था. सो यू हैव टू गिव मी द आंसर इन टर्म्स ऑफ व्हाट आई आस्क्ड द क्वेश्चन. अपना नया आंसर क्रिएट करके साइड में नहीं लिखना है, ठीक है? सो वर्टिकली द एयर मूव्स and horizontally the air moves. This is how the air moves at which pressure? Low pressure. ये भी कहीं साथ में लिख लेना है. At low pressure, air moves vertically. Low pressure, air moves vertically and horizontally. वो साथ में लिखना है. This is the rule that you have to somehow remember. Right? यार रिमेंबर करने का कुछ जरूरत ही नहीं, किसी भी जगह पे हिट कर देना, अपने आप समझ में आ जाएगा लॉजिकली क्या होना चाहिए. ठीक है. So horizontally in and vertically out. Please do write that. Low pressure means horizontally in, vertically out. ठीक है. Now as this air will go up, ठीक है, it will tend to rise and go up. Alright, like this, ऐसा करके, and it will go up to tropopause. We have learned that. And will it go beyond tropopause? No. So it will tend to. So if air is coming from below but the top air is not being moved, then what kind of pressure will I get there? So in the upper region I will get a high pressure. Do we get it? In this upper region we will get a high pressure condition. Why? Because more and more air is coming from below. Because of this more and more air coming from below, the upper air will tend to go sidewards. ठीक है. So this upper air will tend to hence move sidewards. ऐसा. And did you understand that high pressure? So that high pressure, is it because of heating cooling or it is because of more winds coming into that region? So mechanical or thermal? This is mechanical. So this high pressure is created mechanically. M is mechanical. है समझ में? So you have a low pressure created thermally and above it you have a high pressure created mechanically. इतना समझ में आ गया? ठीक है. And you can also see the wind movement. So at the high pressure, how is the wind moving? Vertically. At the high pressure, how is the wind moving? Vertically. Vertically, inward, and horizontally. वो भी लिख लो. High pressure, the wind is moving vertically, inward, and horizontally, outward. Okay, now let's do the same exercise at the other cooler end fast. यहाँ करें cooler end पे. So what should happen? The air will become cold and hence it will tend to contract. है ना? So this air will tend to become cold, therefore it will tend to contract यहाँ पे, and if it contracts it becomes denser or lighter and hence tends to sink down. है ना? So it will tend to sink down. So vertically the air will tend to sink down, cooler region. ठीक है. And if it sinks, will it put more pressure or less pressure? So what type of pressure should I expect here? I should expect a high pressure in this region. High pressure. And is it created due to cooling, heating or mechanical movement? ये क्या है? The air got cooled or just moved like that? So किसका वजह से है ये? Thermal. So this is a high pressure created thermally. So अभी तक आपने दो टाइप का हाई प्रेशर देख लिया, mechanical and thermal. Is it clear? And how will the wind move horizontally from here? Inward or outward? Outward. So यहाँ से wind will move horizontally outward. अब ऊपर देखो रूल में क्या लिखा है, यही लिखा है ना, हाई प्रेशर वर्टिकली एंड हॉरिजॉन्टली. तो फिर से लिखने का जरूरत नहीं है. सो वेदर इट इज मैकेनिकल और थर्मल डजंट मैटर, राइट. हाई प्रेशर ऑलवेज मींस वर्टिकली एंड हॉरिजॉन्टली. ठीक है, आया समझ में? क्लियर? नाउ प्लीज सी हियर, this descending wind from above, this wind which is descending from above will descend from near tropopause. So because of that, what will it create near tropopause? More air or less air? So pressure. And hence what type of low pressure is this? Movement or cooling? So this is a low pressure created mechanically, wind moving vertically out या in, and hence horizontally क्या होगा? लो प्रेशर है तो wind will try to come and fill that place. So horizontally it will move. लो प्रेशर यही लिखा था ना, चेक करो. Vertically out, horizontally in. So what I am trying to make you understand here is thermal mechanical does not matter. The pressure, it depends on the pressure. If it is low pressure, it will be vertically out, horizontally in. If it is high pressure, it will be horizontally in, sorry, horizontally out, vertically in. आगे समझ में? और ये आप कभी भी कहीं भी बना सकते हैं. कोई आधी रात में भी उठा के पूछे लो प्रेशर पे क्या होता है, रुक जाए यार पेपर पे ड्रॉ करना है, 10-20 सेकेंड लगाओ, अपने आप निकल आएगा सब कुछ. You get it? Your logic should be right. लॉजिक गड़बड़ किया तो एग्जाम में भी गलत हो जाएगा. Is that okay? ठीक है. So आगे बढ़ जाएं. So how many types of pressure did you understand? 4. 4? 2. Which are they? And how are they created? Mechanically and thermally. And how will the air move? You understand that? आ गया समझ में? And if you see the whole picture now, what do you find? Can you see a cycle? है ना? So this is how the air creates a cycle between a high pressure and low pressure on the surface and high pressure and low pressure in the upper atmosphere. आया समझ में? So this is how your high pressure, types of high pressure and low pressure. And one more thing that you understood here was, if I ask you on the surface horizontally, how is the wind moving from which to which pressure? Horizontally on the surface. And vertical and in the upper atmosphere? In the upper atmosphere, how is the wind moving? High to low. And on the surface? यार आप लोग सब कुछ बोल देते हो मिल करके. साफ साफ बोलना है एक बार में, ध्यान से सुन के. On the surface, horizontally, high to, everyone agrees. In the upper atmosphere, horizontally. So wind is always moving horizontally. अपर और लोअर से फर्क नहीं पड़ता. जैसा उधर थर्मल मैकेनिकल से फर्क नहीं पड़ा, वैसा ही अपर लोअर से फर्क नहीं पड़ता. विंड हॉरिजॉन्टली ऑलवेज मूव्स फ्रॉम, और एयर नॉट विंड, एयर ऑलवेज मूव्स फ्रॉम हाई टू लो. सो दिस एयर मूविंग फ्रॉम हाई टू लो हॉरिजॉन्टली और नियर हॉरिजॉन्टली इज कॉल्ड एज विंड. इसी को विंड बोलते हैं. एयर मूविंग हॉरिजॉन्टली और नियर हॉरिजॉन्टली फ्रॉम हाई टू लो is known as wind. ये लिखना है हमें. ठीक है. So what do we write? That horizontally or near horizontally. Why am I saying near horizontally? Because this can happen even on a slight mountain slope. तो वहां पे तो horizontal नहीं रहेगा, near horizontal हो जाएगा, है ना? So you can write. What did I say? मैं भूल जा रहा हूं यार आज. Horizontally or yeah, so air moving horizontally or near horizontally between, और between की जगह from कर दो, from high pressure to low pressure, high pressure to low pressure, either near surface or in the upper atmosphere, either on the surface or in the upper atmosphere, is known as winds. Is known as winds. Is that okay? Now see the vertical thing. Vertically कुछ दिख रहा है? One side the air is moving from low pressure to high, और दूसरा हाँ low pressure to high. तो ये तो उल्टा हो गया wind का, है ना? But is it low pressure really? Now you have to see this. अब थोड़ा ध्यान से देखो. And this is, as I said, probably the last part. Now if this is a high pressure, let me say this is 1020. ये जो है high pressure is something like 1020 millibar. So this low pressure should be less than 1020. So ये 1010 हो गया मान लो. So you have a low pressure and high pressure. But what should be the value of this upper high pressure? Should it be more than 1010? Now when you go near tropopause, you are already 8 to 18 kilometer high. Will the pressure be same as the pressure on the surface of Earth? No, which means the pressure would invariably be high or low as you go higher in the atmosphere. Pressure. So if you are up by 8 to 18 kilometers, the pressure would always be, which means both these upper atmosphere high and low with respect to the surface pressure are always low. तो इसका वैल्यू कितना होगा? ये हाई प्रेशर माइट बी 500 मिलीबार and the other high pressure might be low pressure will always be less than this, so ये होगा 480 millibar. Sir, just for example, अब देखो, once you put the values, does the perception change? हाँ? Is it high pressure with respect to this low pressure? नहीं है. So when you say high pressure and low pressure, you are comparing only horizontally. You never compare vertical high and low pressures. Do we get it? अगर आपने अपना नंबर टॉपर में लोअर वाले से भी कंपेयर कर लिया तो दुखी हो जाओगे. तो कंपेयर किसे करना है? अपना फ्रेंड से. ऊपर वाला फ्रेंड से कंपेयर नहीं करना है, फिर दुखी हो जाएंगे. इज दैट ओके? सो कंपेयर हमेशा साथ वाले से करना है. अंडरस्टूड? So we always compare pressure horizontal at our level. ठीक है? क्योंकि लेवल का हिसाब से ही फ्रेंड बनता है ना. ओके तो दूसरा लेवल पे फ्रेंड बनाना भी नहीं है ज्यादा, ये नहीं सोचो. नहीं तो सर फिर तो आगे बढ़ेंगे ही नहीं लाइफ में. तो बनाना है, बट धीरे धीरे फिर अपना लेवल भी उधर तक ले जाना है. ओके सो व्हाट डू यू गेट इट? व्हाट डू वी अंडरस्टैंड? Do we talk vertically of pressure comparison? No. So इसको बोलते क्या है? Do we call these movements as winds? No, this is not wind. This is called as draft. ठीक है? The wind that moves vertically up is called as updraft. The air that moves vertically down is called as downdraft. So vertical movement of air is not called as wind. ठीक है? Only the horizontal movement of air is called as wind. And only horizontal movement, for that we only compare horizontally the pressures. We never compare vertically the pressures. Is that okay? ठीक है, आया समझ में? So do you understand the difference between wind and draft? Draft is vertical and wind is, and how do we compare pressure? Always horizontally. And in that horizontal comparison, we'll always get a high pressure and a low pressure, and we'll always find that the wind is blowing from high pressure to लो प्रेशर. आगे समझ में? इतना क्लियर है? सो नेक्स्ट क्लास वी स्टार्ट फ्रॉम हेयर. कब है नेक्स्ट क्लास आपके साथ? हाँ, ट्यूसडे. ओके, परफेक्टली फाइन. सो कल थोड़ा सा तब तक पढ़िए, राइट? एंड यस डियर, एनी डाउट? बोलो बोलो, लिसनिंग. व्हाट इज द लैप्स रेट ऑफ प्रेशर? आई वोंट रिमेंबर राइट नाउ. गूगल मारो, देखो. अलग अलग, हाँ वही चक्कर है. दैट्स व्हाई वी डोंट हैव अ कांस्टेंट वैल्यू देयर. So I don't remember that range also. अभी मेरे को रेंज भी याद नहीं है. एक बार क्रॉस चेक कर लो. ठीक है? So that's it. Thank you, sir. Anything you want me to take up? Okay, nothing. हाँ जी, बोलिए. Is it the latitude which plays the role in? Latitude या altitude? क्या बोलना चाहते हो? Is it the altitude because of which? Yes, because at different altitude the pressure decreases. ठीक है? So any other doubt you have? किसी का भी? आ जाओ, बाकी चले जाओ. Thank you. Sir, which chapters do we have to read? I think it is chapter number 13 and 14 of GC Leong, and there is a complete section of climate in your NCERT. Fundamental of फिजिकल ज्योग्राफी, क्लाइमेट का पूरा एक सेक्शन है. सो यू रीड ऑल द चैप्टर्स ग्रेजुअली एक्सेप्ट फॉर द लास्ट, वर्ल्ड क्लाइमेटिक रीजन्स.